Hide the planet! Hide the planet!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat. And we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. All right, so what are we doing today? Each stream we like to do 4 topics. That's what we do on the channel. So if you've never been to the stream before, we like to publish a schedule for our weekly streams. I don't have the next week's stream schedule up yet, but we do have the final day for today up on the Reddit over here. And our first topic is going to be some coding. We're going to be doing some coding in Python over at the Leetcode.com website. Leetcode is a very well-known website for learning how to do programming, solving different problems, and being graded on a score. I'm not so much interested in being graded on a score, but I would like to sharpen my coding skills. So we're going to be doing that, and you're very welcome to join along with us. So that's going to be the first hour. In the second hour, for the second topic, we're going to be doing HackerFrogs AfterSchool. So we're going to be wrapping up our web app hacking topic with this session. If you're interested in learning about web app hacking, I highly recommend you go to the previous streams and take a look at the second hour of each one of those broadcasts. You're going to see these for the last 7 weeks or so. And today we're going to be talking about Burp Suite, which is a very common security tool that people who do web app hacking do. And we're just going to be talking about how to interact with the program. Okay, so that's the second hour of today's stream. In the third hour of today's stream, we're going to be doing some demonstration of binary hacking. So binary hacking is a very specialized skill, but I'm going to try to explain some basics about binary hacking, and that's going to be in the third hour. We're probably not going to take up the full hour with this, but with any other time that we have, we're going to move into the fourth topic of today. So the fourth topic is going to be software hacking challenges. So these are mostly binary hacking challenges over at the OLIcyber.it website. So training.olicyber.it. It's an Italian cybersecurity education platform, and we've been using it for quite a while to learn more about all sorts of different cybersecurity stuff, not just software hacking, but web app hacking and some other stuff as well. So please look forward to that in the fourth hour. And without further ado, let's go ahead and start the timer for the first topic, which is going to be leet coding. All right, so we've got a list of different challenges we're doing over at Leetcode. If you don't have an account at Leetcode, you can make one for free, and we can do these challenges together. So I've got a list of easy challenges over here. The easy challenges are, well, they can be a little bit tricky sometimes, especially for people who are new to coding like me. I know how to do, I know to code in Python, but actually building stuff out of the code can be a little tricky sometimes. So the Leetcode problem we're doing today is this one over here. And this one is called defanging an IP address. I chose this one because it seems like something that might be relevant to cybersecurity, because in cybersecurity, you're often dealing with IP addresses, and you want to do what is called defanging. And defanging makes sure that the IP address can't actually resolve. And it's done by replacing the periods in the IP address with brackets around the periods. So for example, we've got here address equals 1.1.1.1. What we want to do is we just want to surround these with some brackets and find a programmatic way of doing so. So let's go ahead and constraints, the given address is a valid IPv4 address. So we're talking about IPv4. We're not talking about IPv6, which is in a different format than 4 numbers separated by periods. Okay, let's go ahead and start our walkthrough. So Shin, hello, nice to see you here. Hello, Shin, nice to see you. How are you doing? We're currently doing this Leetcode problem over here. If you have an Leetcode account and you can make one for free, you can join along with us. And if you manage to solve it, let us know. All right, so you know what? Let's play some music, because why not have music if you can have it? Let's do this music here. Okay, gotta make it a little softer. All right, so let's see. Given a valid IPv4 address, return a defanged version of that address. So let me just copy this and we'll start up our little write-up. So in the write-up, we need to provide a bunch of things. We need to provide our URL, our concept, our instructions, and our code. So this is for challenge number 1108, defanging an IP address, and here are the instructions. Okay, and the concept, I guess what we need to do is we need to do some string substitution. Okay, and I'll get the IP address for the challenge, and then I can plug it in. Okay, Shin says, sorry, it's almost 4 here, so I should probably go to sleep. I'll watch it when I wake up. Happy hacking, HackerFrogs. Thank you very much, Shin BDR, and yeah, get some good sleep, and we'll hope you can catch the video afterwards. Okay, so we're doing string substitution in this case, and let's talk about it. So in the challenge here, we've got a sample solution. Well, they've got what we're supposed to provide here. So class solution, define defang IP address, self address string, and so okay, so the address is going to be a string like we've got over here, and we're just going to copy what's here, and then we're going to start making a solution ourselves. And let's go ahead and go over to our coding window. So we've got 2 windows over here we're going to be working with. We've got one window that we're going to be using to run the code, and we've got another window that we're going to be using to write the code. So to write the code, oh, I don't know. Let's make a directory for this. We'll call this defang. Okay, and let's create a file called defang.py. Okay, and oh, you know what? Let's start nano with the lines, with the line numbering. So that way we can, if there's some sort of problem with in our code, we can refer to the line number and then start, it's easier to reference then. Okay, I'm gonna paste in the stuff we've got here, class solution, defang IP address, self address, str, and we need to write some stuff in here. So inside of the class solution, we need to do something with the string. Oh, the address which is going to be the string. Okay, so the address is a string. What we want to do is we want to. I guess what we could do. I wonder what the best way to do this is, because we got these dots. So I don't know. So for an example, let's make an example down here. Okay, so an example address would be, I don't know, 127.0.0.1. What we want to do is we want to use the Python code to substitute out something like, I don't know, defanged equals 127.0.0.1, but we want to replace each instance of the dot with a, what is it? With a bracket dot bracket. Bracket dot bracket. So how do we do substitution in Python? So, you know, let's do a little bit of Googling. Python character substitution. And let's see if string replace. Okay, so replace method is a built-in string method that allows you to replace occurrences of a specified substring with another substring. So we got hello world, and myString.replace 0 with x, print new string results in hello x were x URL'd, okay, like this. So .replace. So .replace is a built-in method. That means we don't need to import any libraries or modules, which is something we don't want to do if we don't have to. Okay, so new string, or defanged equals address dot it's called sub replace. Okay, and we have to replace the dot with the brackets over here. Tufacho, hello, nice to see you here, and welcome to the stream. We're just doing a little bit of leet coding over here. We're doing this leet coding exercise here, if you want to try it out yourself. So this doesn't seem super difficult, which is nice. Okay, so I guess all we need to do is we just need to return defanged. Return. Okay, and let's see if this works. Khaled Anu says, hello, I'm doing okay. Khaled, how are you doing? We're just doing a little bit of programming right now. And let's see. So, return defanged, I guess solve equals a solution. And we do, let's see, solution dot run solve dot defang IP address. Print run. Okay, so we'll give it a string, and we'll just give it 127.0.0.1. Okay, so this is, wow. I didn't think that that the solution would be this short, but let's give it a try. So Python, we're gonna run. We need to go into the defang directory, and then we need to run it. Brian says yes. Hello, nice to see you here. What is up? So we're gonna run Python. What is the name of the file? defang.py. Okay, Python defang. Okay, and we get the correct string. That's good. So this seems to be, turns out that this was a lot easier than I thought it would be. Well, let's see if it works. Copy it, and then we're going to provide it to Leetcode here. So we're just going to delete everything. We're going to paste in our solution. Oh, okay. The solution has a. Hold on. Let me get the solution without the line numbers. Okay, let me get out of here. Cat defang. All right. Okay, and then we'll paste it in, and then we will run it. So test case, what do we got here? So 1.1.1.1, we got 255, 150, 0, and then we were going to test the result. You must run your code first. Okay, let's run the code, and it's this button up here. Brian says, rainy day at home, chill. Yeah, it's super rainy and cold over here as well, where I am. Okay, run the thing. And we got accepted. Okay, so case 1 was accepted. Case 2, yeah, we got the expected result. And let's see. So case 1 and case 2 both return okay. And let's see, contribute a test case. I don't think we need to, but yeah, all right. We got a working solution. So let's go ahead and. Do we submit this? What do we got here? Run a demo. I guess we'll submit this. And accepted. Great. beats 66.71%. Memory beats 88.87. Great, okay. And let's go ahead and go over here. So the code we've got is this. All right, so let's. I guess we could include the rest of the code as well. Just the, so we can show exactly what it does. Okay, let's. I think this is all we need here. Chris says, submit runs more tests. Submit runs more tests. Chris, are you a person who does a lot of Leetcode? Let me know. Okay, so we've finished 2 of the challenges on the list. We got defanging, we got score of a string. Let's see if we can find another challenge to do. Hold on. Okay, so what are the names of these challenges here? I want to do something that sounds a little bit more fun. Find words containing character. Find words containing character. This sounds like something you do on a very regular basis as well. So we're searching output for certain strings. That's what I'm guessing. Chris says, not much nowadays, but it's a cool tool to learn data structures and algorithms. Yeah, I mean, we can all do with a little more practice with our coding. Especially since the more literate you are in coding, the more powerful you become. The more powerful you become. Of course, you don't need to necessarily learn how to do coding to get into cybersecurity and do hacking stuff, but it certainly does help. Okay, so let's go ahead and start the next challenge. Okay, so we're going to commit these changes here, and then we're going to start our next walkthrough. The reason why we write up walkthroughs for each one of the challenges we do is that if you don't record something, if you don't document it in cybersecurity, then it didn't happen. Okay, so what's this next challenge? So find words containing character. Let me just copy this. Okay, so we're just going to... Well, I don't think we're allowed to have dots in our file names here over at GitHub. Okay, so we got the name. We've got, we need to provide some information here. 1001 Agency says, hello again. Hello, 1001 Agency. You caught us at a time where we're doing some coding stuff. So the URL of the challenge, the instructions for the challenge, the concept for the challenge, and the code to solve the challenge. Okay, let's go ahead and fill these out. What's that 3D puzzle game that you usually play? The 3D one? The 3D one is The Witness. Let me type it in. That one over here. Okay, so the URL, let's get the URL of the challenge. Don't think we need to have this open anymore. And if you want to do this challenge yourself, this is the link. Okay, so let's see. The URL is here. The instructions we need to get from the challenge. So you are given a 0-indexed array of strings, word and character, a 0-indexed array of strings, words, and a character X. Return an array of indices representing the words that contain the character X. Note that the returned array may be in any order. Okay, sure. Let's go ahead and copy these instructions. And we'll copy them over to here. Okay, the concept in this case is... Let's take a look. So they've got example, input. Let's put this stuff away for now, and we'll make the window a little bit bigger. Okay, example 1, words equals leet and code, and x equals e. So they're looking for the letter E. Output is 0 and 1. Explanation: E occurs in both words, leet and code, hence we return indices 0 and 1. Indices 0 and 1. Okay, so this is a boolean. So the boolean is, does the string exist in the, does the character exist in the string? So does E exist in leet? Yes. And does it exist in code? Yes. So we need to return a list, and in the list it's going to be the indices, or the item index where each one of these occur. So leet is 0 and code is 1. So we need to return this list. Alright, great. Let's take a look at example number 2. Bit says, hello, I'm earlier now on stream. Great, nice to see you here, Bit. And let's take a look at example number 2. So the words, we got 1, 2, 3, 4. We got 4 indexes in here. And we've got the letter A. So output is 0 and 2. So this is 0 here. It contains the letter A. And this does not. And then this does. So this is 0, 1, 2, 3. So it's only 0 and 2. Okay, and we've got example number 3. We've got 1, 2, 3, 4 indexes. So that's 0, 1, 2, 3. And x is equal to z or z. So this is not in any of these indexes. So we just return an empty list. Okay, z does not occur in any of the words, hence we return an empty array. Okay, so let's see. Words length is going to be 1. Well, it's going to be at least 1, and it's going to be at maximum 50 different arrays. Okay, or 50 different indexes. Let's see. The length of the objects in the word are going to have a minimum length of 1 character and a maximum length of 50 characters. Okay, and X is a lowercase English letter. Words consists of only lowercase English letters. Okay, so everything's going to be in lowercase. That's a good constraint to know. All right, let's go ahead and copy the solution code here, and then let's create a new directory for this challenge. Let's see. Let's say that this challenge is called letter in list, because that's kind of the vibe it gets me thinking about here. All right, and we're just going to make our Python file. We're just going to call it letter in list as well. .py. Okay, and we can paste in the code we got from Leetcode there. Oh, this isn't what we want to do. This isn't the thing. Let's get rid of this. Let's grab the code. Thought I copied that code. Can I just, well, let me just do the keyboard shortcut. Okay, good. All right, and let's move into our directory here. And what's going on? So class solution, define find words containing self words list. Words is a list, which is a list with strings inside, and X is a string. Okay, so we need to create some code in here, and just for fun, let's remind ourselves what we're doing. So words is going to be a list. So it's a list of different strings. Let's suppose it's got 3 strings in here. So we got ABC, we got XYZ, and we got WWW, or we got, I don't know, ABZ. So, and what is it? X is equal to a letter. So the letter, let's pretend we're looking for the letter A. So the supposed, like, the solution has to return, solution must return in a list with the indexes where the X variable exists. So the X variable in this case is A. In this case, the example solution would be zero and 2. 0, 2. So example solution, okay. So what are we supposed to do here? I think we need to define some things inside of the class here. So, well, I mean, okay. So this is the function. The function's called find words containing. Find words containing, okay. And we're just going to create an empty array or an empty list. So has letter equals empty list. As we go on, we have to populate this list. So has letter has to be populated with the indexes where the letter exists. Okay, so we need to run a for loop. So for length of list, for x in range, length of the list -1, or is it length of? It is the length of the list, right? Let's see. Length of words. Do something. Okay, so for x in range, length of words, we need to iterate over the list. So x is equal to, actually, maybe let's not use the word x, because the word, well, let's not use the letter x, because the letter x is already used in the variables here. And for item in range, length of words. If x is in the item, then do something. So if x is in the item, then it qualifies, and we have to add this. We have to add this. What is it called? This object or this index. We need to add the index to the list of has letter. But how do we do that? Do we need to use the enumerate function again? So in our initial last week when we did our first Leetcode, when we did our first Leetcode session, we found out about the what was it called? Enumerate Python function. So the enumerate function in Python is a built-in function that adds a counter to the iterable and returns it as an enumerate object. Though this object can be iterable and returns an enumerate object. Okay. But I guess we could also. A bit says I have some questions. What's the motivation that pushes you towards practice? Because I feel like I'm stuck learning just theoretical stuff. I mean, okay, so you feel like you're stuck learning theoretical stuff, but what kind of subject matter is it? Do you mind telling me what you're learning right now? That seems a little bit boring. Because if you can find a way to link the theoretical stuff to something practical, it'll help you learn. It'll help you learn that theoretical part. So, I mean, for me, I'm trying to learn about Python by doing some coding. So the coding is the practical part, and the Leetcode exercises here are the real world challenges that we need to use the the coding stuff to solve. Okay, so what are we doing right now? Okay, so we need to. So we've got has letter. This is the list that we populate here, and for item in range length of words. Length of words -1. I guess length of words -1. The length of words, but we want this to be 0 indexed as well. We want it to start at 0. We want it to the range to start with 0. Well, I mean, it starts with 0 by default, so we don't need to do that. Never mind. So if X is an item, then we need to add. How do we reference? Okay, let me ask the question to good old Claude. So we're doing a Python exercise. We have a list of strings, and we want to check to see if the string contains a letter. We want to create a for loop which iterates over all the items in the list. But how do we, if the item has the letter, the target letter, a target letter. If the item has the target letter, we have to add the index of the item to a list and return the list. How do we do this? So specifically, what I want to know is how do we make sure that we can reference the index of the item? Okay, find indices, string, what do we got? More traditional index-based loop, list comprehension one-liner. Complete examples. Okay, go down here. The recommended approach is method 1 using enumerate as the most Pythonic and readable. So we used enumerate in a previous exercise. Psyched, hello, nice to see you here. Welcome to the stream. We're doing some Leetcode practice right now. If you want to do this yourself, then Bit says never realized that before. Thank you for the answer. Yeah, I mean, if you want to give me an example of what you're learning and how you could, potentially make it a practical thing to better understand it, let me know what the actual subject of your study is. Maybe I can help come up with a solution. Okay, so what do we got? Okay, so multiple conditions. Indices equals something for is in enumerate strings. So is, so index string in enumerate strings. If letter in S and length is less than 5, indices.append I. So, I mean, this seems like a pretty cool solution. It fits in with most of what I have already. And I guess what we're doing is we're running enumerate on the string, but enumerate strings. So strings is the list. So for is in enumerate strings, I'm assuming that enumerate also takes care of the length of, you know, making sure that the list can be of any length. All right, let's go ahead and see if we can plug this in. So has letter equals the list. Let's get rid of this. We'll plug in this over here. So has letter is the name of our thing. Bit says I'm learning XSS right now. Okay, so are you trying to figure out how you can turn the theoretical XSS stuff into practical exercises? Because there's lots of stuff for XSS. Like I can point you towards stuff for XSS right now. So let's see. There's Portswigger, which is our favorite website for learning about security stuff. Cross-site scripting, how to prevent it. There's labs associated with this as well. So as you go through this section, there are some labs for you to work through. View all labs over here. You can make a free account over at Portswigger. Nothing on well, not nothing, but all the labs on Portswigger are completely free. And where else can you learn about XSS? You can probably learn about it over at TryHackMe as well. There should be like a free lab over at TryHackMe that deals with cross-site scripting. Let's see if I can find it. View all, room, cross-site scripting. Let's see if we've got some free ones. Yeah. Okay, so there's this one here. Let me copy this link for you. Here you go. Cybernerd Dante says the Google XSS challenge is also helpful. Yeah, Cybernerd Dante, if you've got a link, that'd help a lot. Thank you. Of course, if you're busy right now, you don't need to do that. Okay, so what do we got? So for is in enumerate strings, so enumerate strings. It's not strings in this case; it's words. Okay, so for index, actually, I guess we could do this for item. For item and string in enumerate words, if x is in the string and the length of s is the length of the string is less than 5. I mean, we don't need this restriction. We're just gonna leave it out. Has letter dot append I. So yeah, I think this should work. This should work. We'll give it a test case. So solution. So solve equals item from the solution class. So run equals solve dot find words containing. Then we need to feed something in here. Hold on. Let's copy this word list and we'll put it up here. Okay. Copy this whole thing. We're just going to call this word list. you know, just so that the names of the variables don't. Words list and letter, target letter equal to A. Okay, and the last thing we need to do is we need to return the has letter over here. So the for loop will run. At the very end, we need to return has letter. Okay. And let's get rid of all this. And we can get rid of this too. So print run. All right, let's see if the solution works. So we got oh, we need to run it with our arguments, because without the arguments it doesn't work. Let's see. So we got, so the first thing is going to be words equals words list, and x equals target letter. All right, let's run the code. Python, what is this called? Letter and list. Has letter.append, indentation error. Okay, so this is line 6. Ah, okay. All right, there's an indentation error. This needs to be indented. Okay. This is why we run nano with our lines, so we can identify where the lines are. Okay, run it. Class solution, return has letter. Name list not defined. Did you mean list? Oh, okay, so we shouldn't use the word. Yeah. Okay, so words, self words list string. List string. Okay, so it's not supposed to be enumerate words, it's supposed to be enumerate list. Alright, and do we need to adjust anything else? Name list not defined, did you mean lists? Lists. Oh, it doesn't like... Wait, isn't this exactly what we copied? This is exactly what we copied from the Leetcode site. Why would this be wrong? Okay, Chris says it is words. Oh, okay. So yeah, all right. I misread that. So self words is going to be a list with strings, and x is going to be a string. Okay. So the name list is not defined. Did you mean list? So I think it might be. Enumerate words. Enumerate words. Words equals word list. X equals target letter. You named the index as item, and you append I instead of I. Oh, that's right. That's true. Okay, so this is what the debugging is for. For item. Has letter.append item. So item is item in string. So append item. This might not work, because this is, well, I mean, item is item. This shouldn't be item. This should be index or item index. But that's making it long, because it shouldn't be called item. but so list is not defined. Did you mean list? So we need to we need to make sure that this this uppercase list is a lowercase list instead, because that's a keyword in Python. Okay. Yeah, so now we've got 0 and 2. So this is expected. So this looks like it could be the working solution here. Return has letter, so we just need to make this a little bit more clear. So items index. For items index string and enumerate words, dot append items index. It is a bit wordy, but I'd rather have variables that that are easy to understand than have variables that are short. Okay, so this is a working solution. We got 0 and we got 2. I think this is what they're expecting, and let's just grab this. So this is the code, and we will go back to Leetcode. So the strange thing is that they're using the capital L here for list. I'll change this over to the capital L for list after I paste in the solution, just so that it matches up, because I'm not too sure what they're trying to do with this. List is old stuff from the typing module. Is it? I really don't know about that. Okay, let's run the thing. Okay, are we good? So Leetcode E equals E, output 0, 1, expected 0, 1. Okay, this is good. Case 2. Words equals ABC, these 4 things. X equals A, expected 0, 2, got 0, 2. Okay, or got 0, 2, expected 0, 2. That's good. Case 3. ABC, blah, blah, blah. Okay, X is equal to Z, and none of these have Z in them, so expected and output are the same. Okay, so this should be good. We'll just submit this and see what happens. Okay, runtime beats 100%. Memory beats 67%. Okay, well, I mean, we don't really care about being competitive here. We're just looking for working code. So it looks like this works. I don't know if we're going to be able to do one more of these, but we can get started, I suppose. Okay, we can go ahead and copy this and put it in our write-up. So it turns out that the enumerate function comes in super handy when you're iterating through a list and you're looking for indexes. Let's go over to our write-up, concept code. So for anybody who doesn't know, we're recording all of our stuff over at GitHub, and GitHub is really nice because GitHub supports Markdown in the files that you create. Markdown is a very easy way of creating formatted text. Okay, we got our code, and we've got our instructions. What's the concept? So the concept for this challenge is finding strings. Finding strings in list objects and iterating over lists. Okay, let's commit these changes. This is done. And we got 3 challenges done so far. That's great. Jason IT Solution, hello, where are we? Yeah, so we just finished another challenge over at Leetcode. And we're working off of this list over here. Okay, so we solved 3 of these. Let's take a look at what else we have here. So we're looking for some fun challenges. Let's see. 2 sneaky numbers of Digitville, richest customer wealth. I mean, richest customer wealth, that seems like it could be fun. Let's click on that. We also have jewels and stones. Convert date to binary. Convert the temperature. Convert the temperature also seems like something that we'd be doing a lot, converting one from one system to another system. Convert the temperature, sure, why not? Let's get this started. We might not be able to finish it today because we only have 12 minutes left. All right, so here's the here's the challenge link. And before we get started, I'll start up my walkthrough. So we got some files over here. The new file is going to be convert the temperature. So this is why can I not highlight this text? Let me highlight the text. Okay, there you go. Okay, so this is in Markdown file. So this is challenge this one, convert the temperature. Okay, so for each one of these challenges, we're recording a number of things. The URL of the challenge, the instructions, the concept behind the challenge, and the code. So let's grab the URL and the instructions. So what are the instructions? Okay, this is the previous one. So you are given a non-negative floating point number rounded to 2 decimal places, and this is called Celsius, that denotes the temperature in Celsius. You need to convert Celsius into Kelvin and Fahrenheit and return it as an array. So the answer is going to be Kelvin and Fahrenheit. Return the array answer. Answers within 10 to the minus 5 power of the actual answer will be accepted. Answers within 10 to the minus 5 to the minus 5 power of the actual answer will be accepted. That kind of I'm not a math person, but okay, so please note that, okay, Kelvin equals Celsius plus this number. So Fahrenheit equals Celsius times 1.80 plus 32. Times 1.80 plus 32. So if I've got my mathematics correct, we need to do this calculation first before we add, because we always multiply before we add. Yeah. Okay, so input 1, Celsius equals this. Output equals this number and that number. Okay. Alright, well it seems pretty straightforward. Constraints. Celsius is going to range from 0 to 1,000, okay? Alright. Let's get started then. I'll copy this over here, and we'll copy it over to the instructions at the GitHub. Where is it? Here. Okay, so the concept in this case is conversion of numbers from one system to another system. Okay, so let's go ahead and get started then. So we got here. And let's go ahead, start this up. We're going to create another directory for this. We're just going to call this convert temp. Okay, and we'll do the same thing here. We'll enter the directory convert temp. And here we're going to use nano to create a new Python file, convert temp.py. Paste in the initial code. Okay, so we got ads running on... Oh, we don't have ads running right now. Okay, sorry, we're going to have ads in just a little bit. During the ad, we'll take a little water break. Okay, so let's see. Convert temperature. So I guess when we're ready to run our solution, we're going to have to create our object in the class, the solution class. And then we're going to have to run the convert temperature. Temperature. We have to run this function with, I don't know, Celsius is going to be a float. Example temperature, we're going to... Jason IT Solution, please help me track where the challenges using... What? Where the challenges we're using are for Leetcode. Yeah, so we have a list of the challenges that we're doing over here. You should be able to open this up in any browser. Let me do a quick check. Yeah, okay, you should be able to open up that link, and it'll tell you all the challenges that we got on the list. So we're currently doing this one here. If you want to take a look at all the other Leetcode stuff that we've been doing, then I think you should be able to use this. You should be able to use this link here if you want to take a look at the solutions for our other challenges. Okay, we got a ad running on Twitch, we'll run one on YouTube, and we'll put on some birds. It's time to hang out with the birds. How about these birds? Okay, we'll be back in about 40 seconds. I just need to take a little water break. But enjoy the birds. Okay, let's put the birds away. Let's get back to the hacking. We only have a few minutes left, and let's get as much done as we can. Okay, so what do we have in our code? So we got our example temperature. We're gonna make it's a float. So we'll make this float, I don't know, 20.05. It's supposed to be the Okay, so solve equals solution. Solve is an object in the solution class, and we need to make sure that this is the word list is not capitalized, because it really, well, our version of Python doesn't like the word list capitalized. Let's see. So Celsius, Celsius float. Hold on. So we need to define some things up here. So Celsius is defined. So that's the variable we're passing in. And we also have this other information from the challenge that Kelvin equals Celsius plus 273.15. I mean, we could put this directly into our code. Actually, we can put, well, we'll add these one at a time. Okay. So Kelvin equals Celsius something something, and Fahrenheit equals this. It was very nice of them to give this to us instead of having us guess. All right, so all this stuff is going to be in lowercase. And what we need to do in this case is we need to return an array, or a list rather. So the output is going to be, it's going to be a list with 2 floating point numbers in here. It's going to be, is it Celsius first and then Kelvin? Answer equals Kelvin Fahrenheit. I mean, they tell us right here. We can just go ahead and feed it into our function here. Okay, so answer equals Kelvin Fahrenheit, and my music stopped. Okay, let me go ahead and play the music. Okay, so I mean, we might be able to solve this pretty quick. It seems pretty straightforward. Let's see. Okay, so answer equals Kelvin Fahrenheit. We just need to return it. Return answer. Okay, so we'll save that out, and then we will run the code in this other window. So Python convert temp. Oh, everybody, if you don't spell things correctly, you do not get to hack. Okay. Oh, okay. We need to run the convert temperature with a number. So example temp. Celsius equals example temp. So CS equals example temp. That's not how you spell Celsius. Okay, and then we run the code. An unexpected solution dot convert temperature got an unexpected keyword argument Celsius. Did you mean Celsius? Oh man. More spelling mistakes. Okay, so we need to print that. Print run. Okay. All right. Let's go ahead. No name. Hello, nice to see you here. Sensei is a bit much. You just need to. You can just call me Shy Hat. That's fine. Okay, so example 1 is 36.50. So let's plug in 36.50 there. 36.50, and then let's see if we get the expected. So the expected, it converted to Celsius 309.65. Okay, we got that, and we've got 67.7. Yeah. Okay. So I think we've got it. We've got it, except for it seems that they have a lot of. It's accurate to a lot of decimal places here. So are these all accurate to 1, 2, 3, 4, 5 digits, or 5 decimal places? So these other examples are also 5 decimal places as well. Okay, answers within 5 digits of the actual answer will be accepted. Okay, so I think we don't necessarily need to add on those additional decimal places. Let's see, Jason IT Solutions says, give me an example of the script that you're working on. Explain a bit more so that you can start from there. Yeah, so, I mean, you can go ahead and start the problem. We've got, this is the link for the problem. And the solution we have is this. Let me save it out. I'll be saving it to the GitHub in just a little bit. Okay, so let me just grab this part of the solution and I'll feed it into what is it? Leetcode. So just delete this, paste in our own solution, make sure that the list is capitalized, run the thing to make sure it works. Okay, it's accepted. So yeah, so the test case 2 should also be accepted. All right, this seems to work. We'll submit this. Okay, accepted and beats 100%. All right, great. Let's go ahead and copy this. So convert temp. We will copy this over to our GitHub and then we will complete our walkthrough. Where are we? Here. Okay. Code. All right, let's commit these changes, and I'll give you a link for the thing we're looking at. Convert the temperature. Main branch does not Can I reload this? Okay, now it works. All right, everybody, this is it. And we can move on to the next part of the stream. All right, let's close out topic number 1. It's done. Topic 2 is here. Topic 3 is on deck. And for this portion of the stream, we're not going to be listening to music. But if you're looking for the notes for the stuff we're going to be doing in the HackerFrogs AfterSchool portion of the stream, they're over here. Let's start up that that timer. We're going to be doing this for about an hour or so. But what's going on? Okay, this is HackerFrogs AfterSchool web app. Well, this should be web app number 8. I guess I forgot to rename these. It's number 8 over here. But anyways, what did we learn in the previous workshop? This is the 8th and final web app hacking workshop. In the previous workshop, we learned about the following web app hacking concepts. We learned about union-based SQL injection. I don't think we did union-based last time. Actually, we kind of did do union-based SQL injection last time. So we practice using doing SQL union injection attacks on both the DVWA app, on TryHackMe, and on PicoCTF. We also practice doing the blind SQL injection authentication bypass. And today's topic, we're going to be taking a look at Burp Suite, which is an industrial standard application used for web app security testing. So we're going to be learning this with TryHackMe because we love to use. Well, not everybody has access to a machine with Burp Suite installed, but everybody can have access to TryHackMe because TryHackMe is free. So we got TryHackMe over here. There's a room we're going to be using. Where's the link? No, this is not. It's not it. Okay, if you don't have an account over at TryHackMe, you can make one over at this link. But we're going to be using this room right here to practice using Burp Suite. Okay, so let me show you what the room looks like if you've never done this before. So we're going to leave the room. So if you've never visited that page before, this is what it's going to look like. So once you arrive on the page, and after you've logged into your TryHackMe account, you're going to see this button over here. It's labeled Join Room. Before you can access any of the stuff in the room, you need to click on the Join Room button. So go ahead and click on that. It's going to be the green button on the right-hand side of the screen. After you've done that, you're going to have to click into task number 1, which is labeled DVWA, this header right here. And DVWA is an awesome virtual machine commonly utilized in training and testing of new tools. The room is unguided and acts purely as a testing environment. So we're going to be using this. Go ahead and click on the green start button over here under task 1. After you've done that, you're going to see this red banner appear. It says target machine information. This is where the DVWA application is going to be running after it finishes initializing. So this is a virtual machine on the TryHackMe network, and we're going to get access to it in just about a minute or so. The other thing we need to do is we need to start our attack box to interact with it. The attack box is another virtual machine that's also on the TryHackMe network. And we can go up to the top of the screen here. There is a button that's labeled Start Attack Box. I want you to click on that. And that's going to start up the attack box virtual machine that we're going to be using to run Burp Suite. Okay, so after you click on the Start Attack Box button, you're going to see the web page split into 2 panes over here. So 2 panes of the window. And on the right-hand side of the screen, this is where your attack box is going to appear after it finishes loading up. So that's going to take about 2 minutes. And in the meantime, if you're following along with us, let me know by typing in the chat, Burp Suite is sweet. Burp Suite is sweet with some smiley faces. There you go. Because I mean, if you want to be serious about learning web app hacking stuff, you're going to have to learn how to interact with common tools like Burp Suite. Burp Suite it's a little bit intimidating because it is such a powerful program, and most people who use Burp Suite use very few of the capabilities that the program actually has. Jason IT Solution says, you know, I failed to config OpenVPN and hack the box instance or VM. You know that I failed to config OpenVPN. You don't need to use OpenVPN in this case. So we're using the attack box, which is automatically going to be able to access the stuff on TryHackMe. Are you talking about Hack the Box specifically? Because we're talking about TryHackMe right now. Okay, so after the attack box finishes initializing, you're going to see it pop up over here. Yes, Hack the Box. I mean, I'm kind of teaching people how to use Burp Suite right now. Why don't you come back? Why don't you try asking in the Discord? So let's see. I don't know if you're on the Discord or not. If you got questions about OpenVPN and Hack the Box, maybe you can try asking in the HackerFrogs Discord, and we'll try to help you over there. But yeah, I can't help you with tech support right this minute, unfortunately. Okay, so after the attack box finishes initializing over here, you're going to see the terminal open up. You can click into the terminal, you can hit enter to dismiss the terminal, And then afterwards, what we want to do is we want to make this full screen. So the attack box is, well, it's in half a screen, which is not what we want. So we can just go to the center of the screen and then go down to the bottom. And then we can click on this button right here. It looks like two arrows pointing away from each other. And it's labeled View in Full Screen. Go ahead and click on that. And Denkyako, hello, nice to see you here. Welcome to the stream. We're just doing some try hackney right now. We're going to be learning about Burp Suite, which is everybody's favorite web proxy tool. All right, so after we do that, we're going to see that the attack box is in full screen now. This is what we want, and we can see here that there's a button on the right hand side of the screen. It's this blue icon over here, and it's labeled Burp Suite Community Edition. So this is what we want to use. So go ahead and click on that, and you're going to see Burp Suite start up over here. It takes a few moments to start up. But in the meantime, we can go over to the other Try Hackney page over here, and we can close this out. So we can click on Exit Split View. And that's going to give us back our our full screen Try Hackney page. So what we want to do now is we want to grab our IP address over here, because the IP address, we're going to be using this to access the DVWA app that we're going to be doing our testing with. So go ahead and click on this button over here beside the IP address under Target Information to copy the IP address to your clipboard. Then go over to the attack box, and then click on this button on the left-hand side of the screen in the middle. This is gonna have the clipboard for the attack box. So after you click on the clipboard there, click into it, and then paste in the IP address, because we're going to be using this later. So after you've done that, you can close the clipboard and the control bar here by clicking on this button right here. Okay, so when you start up Burp Suite, it's going to ask you, well, there are a number of buttons that you need to click on to get it started. So click on Next down here, and then click on Start Burp. So these are both down at the bottom right-hand side of the screen. So before I can get started with you, I need to do a couple of configuration things inside Burp Suite to make it a little bit easier for everybody to see. Actually, maybe I don't need to. Okay, let me just go into the settings for a second. I'm going to look up font, because sometimes the font is a little bit small. I'm going to change the font over to 20 point. Okay, and you don't necessarily need to do this stuff. It's just something I'm doing to make sure that everything is nice and visible to anybody who's following along. And at the same time, I can change my theme over to dark mode because we're hackers, and hackers use dark mode, obviously. Okay, we're in dark mode now. Now we can actually do some hacking. All right, what are we doing now? I'm going to close out the settings here. And wow, it does seem a bit cramped now, but that's okay. Okay, so everybody, this is what you're going to need to do. So we're going to go over to the Proxy tab. So from Dashboard, there's going to be there's a bunch of these other tabs here, and the tabs are different tools inside of Burp Suite. And you know what? I should be going through my presentation here. All right, Burp Suite is a web app testing tool of choice for cybersecurity professionals who test web apps. It can intercept the traffic from web apps and do all sorts of stuff with the data. What is Burp Suite? Burp Suite captures and enables the modification of web traffic between the browser and the server, and includes the following 5 tools for web app testing. So I'm going to mention 5 tools. There are more than 5 tools inside of Burp Suite, and among the 5 tools I'm going to be mentioning, you might not commonly use most of these, but let's talk about them anyways. So the first tool is the Burp Proxy. So the burp proxy server is what enables web traffic to be captured and recorded. It sits between the browser and the server, enabling traffic capture. So the thing that we care the most about when we're using Burp Suite is the proxy, because the proxy enables us to capture web traffic. Okay, so there's also the Burp Suite Spider, which is a web app indexing robot which maps out different endpoints inside of a target web app. So the Burp Suite Spider it's a tool that's in the the paid version of Burp Suite. You don't get access to the Spider if you're using the free version, which we're using right now. But the similar tools in the same category include stuff like Derb, GoBuster, and FerrixBuster. So it's basically used for directory busting. Okay, so the third tool is the Burp Intruder. The Burp Intruder is a tool that can be used for different web brute forcing attacks with modular payloads and word lists. So the Burp Intruder is used to do brute force attacks. Notably, the Burp Intruder in the free version of Burp Suite is not very functional, but yeah. Most of the time, if you're not paying for Burp Suite, you want to use other other tools for brute force attacks. So similar tools include Hydra, WFuzz, FFUF, etc., etc. Okay, there's the Burp Scanner, and the Burp Scanner is an automated web app vulnerability scanner which tests all endpoints found in the web app for known vulnerabilities. Similar tools to the Burp Suite Scanner include Nikto, OpenVAS, and Zap. So the Burp Scanner is a tool that is used for automated scanning of web apps for different vulnerabilities, and notably, the Burp Scanner is not functional. We can't use it if you're not using the paid version of Burp Suite. But we do mention it here because it's one of the big features of Burp Suite. And the last tool, which we are going to be using, is the Burp Repeater. So the Burp Repeater is a tool which allows for manual web request manipulation and testing. So it basically lets you replay different web requests, and you can modify the information inside the web requests to test for different types of vulnerabilities. And this is a very, very commonly used tool, especially for people who are doing beginners web app hacking challenges. Well, basically, not just beginners web app challenges, all web app challenges, we're going to be using a lot of the Burp Repeater. So similar tools to the repeater include stuff like Zap and Postman and Charles Proxy. I've used Zap and Postman on a couple of occasions. I've never heard of Charles Proxy. Installation. So while learning Burp Suite, it's recommended to access it via virtual machines or VMs. Let's see. Jason says the Apple example brings out a clear picture for repeater. So repeater, just do the same thing over and over again. We've got a bunch of things. Well, they're kind of the same, but they're slightly different. This is just what I thought of when I came up with with this PowerPoint presentation. Okay, so when you're using Burp Suite, you don't really need to think too much about installation of Burp Suite. I've installed Burp Suite a couple of times, but most of the time I just use the Burp Suite that's installed on the VM. Stuff like Try Hack Me Attack Box or Kali Linux. Most of the time when I'm using Burp Suite, I'm using it through Kali Linux, so you don't really need to worry too much about installation unless you really want to install it on your host machine. Even so, manual installation of Burp Suite is available for all major operating systems from the Portswigger Company website. So I'm pretty sure you can download it for every major operating system, so Linux and Windows and Apple or Mac. Okay, so we're going to talk about the different parts of the problem is that the dashboard is kind of changed from the time that I wrote this presentation to the present version of Burp Suite. But let's take a look at Burp Suite over here. Can we make So here's what I'll say. When you're dealing with Burp Suite, and I think I'll make everything just a little bit smaller so that things are a little easier to see. So let's switch this from 14-point font from 20-point font to 14-point font. Just a second. Now let's see if it looks a little bit easier. It's still Okay, so this is the dashboard over here. Most of the time, I don't use the dashboard inside of Burp Suite. The way you move between different tools in Burp Suite is to just click on the tabs up here. So we got the dashboard, the target, the proxy, the intruder, the repeater, etc., etc. Just most of the time, when I use Burp Suite, I'm switching between the proxy and the repeater tool. So the proxy and the repeater tool are they're probably the most important things that we need to use when we're using Burp Suite. Let me demonstrate. So what I want you to do is I want you to go over to the proxy tab. In the proxy tab, this is the bread and butter of Burp Suite. This is what records all of the web requests. If you go if you go over to proxy and then HTTP history, well, this is the HTTP history tab is basically the thing that records all of your web requests. But the first thing we're going to do is we're going to go over to the proxy and then the intercept tab. So proxy intercept, so this is the main tab and this is the sub tab. We need to turn intercept off. If you do not turn intercept off, then you need to manually accept or drop all of the web requests, which is a huge pain in the butt. If there's any one thing I want you to take away from using Burp Suite, remember to turn intercept off. So there's a big intercept on button here. If it's blue, it's no good. Click on the button and make sure that intercept is switched to off. The other thing we need to do inside of the Try Hack Me Burp Suite instance specifically, we need to click on Settings, and then we need to look up Browser. And then after we've looked up Browser, in the right-hand side of the screen, we have to go down to Browser Running. Where is it? Browser Running. We need to click on this button right here. Why is it? Allow Burp's browser to run without a sandbox. So if we do not click on this button, it won't let us start up the Burp Suite browser, which is another important tool in Burp Suite for testing. So click on the browser running, allow Burp Suite browser to run without a sandbox button, and then we're done. Then we can close the settings window, and then what we can do is we can start up the Burp Suite browser. So the Burp Suite browser, it's a browser that is connected to Burp Suite, and it records all the traffic. Okay, we've got ads running on Twitch. We'll come back after the ad is done. Okay, so I'm just going to take a 60-second break, and then afterwards we'll continue. But in the meantime, check out these birds. All right, we'll be back in 60 seconds. So to anybody who doesn't know, this is my bird feeder. So this is my bird feeder in the backyard. I made it out of an old coat rack. Well, actually, that's not true. It's a new coat rack. I ordered the coat rack specifically so that I can turn it into bird feeder. And I combined that with a bunch of bamboo sticks that I lashed together and a little bowl. And this is my bird feeder. Okay, let's put the birds away. Let's get back to the hacking. All right, so the Burp Suite browser. So the Burp Suite browser it's a very important part of doing the testing. Well, you don't need to use the Burp Suite browser. You could use your own web browser and connect it to Burp Suite yourself, but it's much easier to use Burp Suite's browser when you're doing your web app testing. So let's see. So click on Proxy Intercept. No. So click on Proxy and then under proxy, you're going to see this button here that's labeled Open Browser. So it's going to be, it's going to be on the right-hand side of the screen. Click on it. And if you manage to do everything correctly, the browser should open up in just a few moments. So the Burp Suite browser is a Chromium browser, which is basically, it's like Google Chrome. Jason IT Solution, I think Try Hackney gives you 1 hour for a machine a day on the free plan, so we need to be first. Yeah, I mean, if you've already used your free attack box instance, you're gonna have to set this one out, or you're gonna have to, do this again. Do this again like the next day. So okay, so this is the Burp Suite browser right here. Okay, and it says the title says Portswigger Chromium. Well, I'm going to make this a little bit smaller so that it's a little bit more visible to everybody. Okay, and what are we going to do here? So remember that IP address I had you, oh, it's not here anymore. Let me grab that IP address again. Okay, so over at the Track Me page, under DVWA, I'm going to copy the IP address. We're going to go over to the attack box. And can I directly paste this in? I can. Wow. Wow. Usually you need to go through the clipboard in here, but apparently. Okay, so if you paste in your IP address there, then you can access the DVWA machine. Dan Chiata says, the sooner you install a virtual machine and mess around, the better. The attack box is far from ideal. The attack box is good for people who are starting out, but I agree that you should learn how to create your own virtual machines sooner rather than later. But for people who are just starting out, it's okay. Okay, so here we've got the DVWA application that's running inside of the Burp Suite browser. What we want to do is we want to log in. So to log into the page, we can give the username and password. So the username and password for DVWA is admin and password. So I'll just type that into the chat, admin password. And then click on login. Why is it not letting me log in? Click on login. And then we'll be logged into the DVWA application. Okay, so we just, we just logged into the application. What we can do is we can see what this looks like inside of Burp Suite. So we're going to just minimize your Burp Suite browser. So just, or you can just, drag it off screen. And then we're going to go over to Burp Suite. In Burp Suite, go to Proxy and then HTTP history. So first proxy, then HTTP history. You're going to see all of the requests that we made through the Burp Suite browser. They're going to appear in the list here under HTTP history. So this is the initial GET request right here. We can see all the information that was sent between, oh wow, that is really big. Let me change the font size just a second. Let's make this, I don't know, let's make it 12-point font. 13, 4, let's make it 14. Okay. Okay, so over here in this window, you can just drag this up and down as you please. And this is the all the HTTP and the information that was sent in the request. So you got your headers, your request headers over here, get, host, accept, language, etc., all this stuff here. And then you can see what the server sent in response. So there's request and response. So the response here is a redirection, 302 found. That redirects us to login.php. So we get login.php and we get this in return. So the other thing we can do inside of Burp Suite is we can, inside of the response, you're going to see some tabs over here. So the request over here, the response over here. we can switch this between a few different views. So pretty view, raw view, hex view, and when you see hex view, it gives you the hex rendition of the request. So pretty basically gives you the information here in a very human readable form, and we can also render it out to see what it would look like if it was rendered by a web browser. So the web browser view would look like this. So this is very handy for trying to visualize what's going on the page instead of having to just take a look at the all this text. Okay, so the other thing that that we should pay attention to inside of this post request. So there's get requests and post requests. They're basically trying to get different responses from the web server. So in this post request, we logged in. Remember, we logged in with our credentials. And if we take a look at the request for this, post login.php, go down to the bottom, you're going to see that we sent our information here with the post request. So username equals admin, and password equals password, and login equals login. So if somebody were able to capture this information, they would be able to see your credentials. And because we're sending all this stuff in HTTP, which is not encrypted, anybody who were to capture this web traffic would be able to see all of your information here. So that's something we need to keep in mind. Most of the time, when you're dealing with actual websites, you're not dealing with unencrypted HTTP. You're dealing with encrypted HTTPS. Just something to keep in mind. Okay, so let's go ahead and go back to the web application. So let's see, we can minimize Burp Suite and then click on the blue Chromium window. Where'd it go? Here it is. Okay, and what we're going to do a very simple exercise here. So inside of DVWA, we need to set this application has a bunch of different exercises for us on different web pages here that deal with many different web app security concepts. So there's command injection, there's file inclusion, file upload, etc., etc. What we want to do is we want to adjust the difficulty of the challenges. So we can do that down at the bottom, well, near the bottom of the list, and we want to click on this button labeled DVWA security. So we want to click on that, and it says security level is currently impossible. That means that none of the exercises here are solvable. So we need to change the security level from impossible to something else. So just scroll down here, change this from impossible in the drop-down list to low. So after you switch it to low, click on submit, and then you'll know that it worked because the application now says security level is currently low. So that's good. That's what we want. And then let's do an easy exercise over here. So this one over here is the command injection exercise. So from the menu here, click on command injection. Okay? And then let's see, ping a device. This is the web page here. What we're supposed to be doing in this exercise is we're supposed to be doing some command injection. So the web page here says ping a device, enter an IP address. So for example, if we choose 127.0.0.1, that is localhost, the localhost IP address. Click on submit, and then after a couple of moments, you're going to see something that looks like the Linux ping command. So I mean, the Linux ping command has very specific output, and if you recognize it, then you can identify that the ping command is what is being used by the web application. So this looks very similar, so we can guess that that the application in this case is making use of a Linux command, and that means that we could do some command injection here. So the typical way we do command injection is we give a payload like semicolon and then hashtag. So semicolon, hashtag, and then you put your own command in the middle here. So for example, who am I? So if we give this command here, we're going to get a response www.data, which means we successfully did some command injection. So we can actually take a look at what is going on with this page over at Burp Suite. So we're just going to go to Burp Suite. We're going to go to the bottom. And the bottom, we've got some post requests. So the post requests are the instructions that we sent to the web application with our data. So if you click on the last post request here, you're going to see the request and the response. We sent it to this endpoint here, and we sent these instructions here. So IP equals something something, and submit equals submit. We see the response over here, and what we can do is we can start messing around with this. We can start messing around with the stuff that we send, and what we can do is we can use the repeater tool. So from proxy HTTP history, click on the very last request over here in the list, and then inside the request window, we can right-click and then select Send to Repeater. So this is going to send this request over to the repeater tool. You're going to see the repeater tool light up orange for a little bit, and then you can click on the repeater tool. So you're going to see all of the information for this request in here in the request, and we can send this using the send button up here, over here. So send the request, we can see the response over here. So HTTP 200 OK, and so you can look through the text version of this, but you can also render this out in the web browser view. So we switch from pretty over to web render, and we can see what it looks like if this request was rendered in the web browser. So we're not using a web browser. Burp Suite, well, the Burp Suite repeater tool is not a web browser, but we can see what it looks like if it was rendered by a web browser. We can go back to the request and we can start messing around with this. So we can do, instead of doing who am I, we can do another command. And okay, so we're just gonna delete who am I. We're gonna do, I don't know, LSLA to see what is in this directory. Send that, and in the response we get a list of directories here. So help, yeah. So we're just, Denkiato says, what's the point of the hashtag? Would this not work without the hashtag at the end? It really depends on what the exact application is doing. But the hashtag, it means that whatever is being sent as a Linux command is being ignored. So who am I? And then if we put a hashtag here, we can comment whatever we want. It doesn't consider this as part of the command. And if there's additional commands after what we inject, they could get in the way of our OS command injection. So that's why we use the hash over here. So would this not work without the hash at the end? Maybe it would work, but the reason why we put the hash over there is insurance, just in case there is something else that's going on in the OS command. Okay, so what can we do from here? So yeah, this is just trying to point out that the repeater tool is the most commonly used tool. Well, the proxy tool is the most commonly used tool. But the proxy tool in combination with the repeater tool is your bread and butter when you're working through web app security problems using Burp Suite. There are a lot of other there are a lot of other tools inside of Burp Suite, but most of the time you don't need to pay attention to most of those tools. It Burp Suite is very, very powerful, and I'm only teaching you a very, very small fraction of what the actual software can do. But yeah, if you wanted to, modify which endpoint you're contacting here, you could do that. If you wanted to modify the host you're contacting, you can edit all of this information here, and you can start messing around with this. You can send it and see what the server sends you back. This is very commonly done when you're doing web app security testing. Okay, so how much time do we have left? Okay, so dashboard, we don't need to pay too much attention to the dashboard. Navigation. So navigation inside of Burp Suite mostly comes down to selecting the desired tab on the navigation bar. So most of the time, you just need to go to the navigation bar and click on the tool that you want to use. If you click on a tool, there's usually going to be some subtabs that you can navigate through to get to where you want to. Within a specific tab, you can navigate to the subtabs below the main tab bar. So in the proxy tab, there's the intercept HTTP history and WebSockets history subtabs, and options over here. So it's also a very important thing to know where you can find the settings button inside of Burp Suite. And luckily, they have it over here in the corner. So the upper right corner. The settings inside of Burp Suite, it's pretty intuitive to use. There's a search bar over at the left-hand side. So if you want to look for, make the fonts bigger, you can just type in font, and it will show you where the word font is included. And so if you wanted to look at, I don't know, the Burp Suite browser, just type in browser, and then you've got the pages or the settings pages that have to do with the browser, etc., etc. Okay, so what else? Okay, let's see. Burp proxy. Yeah, okay. The burp proxy allows web traffic to be recorded, reviewed, and replayed. One thing to take note of is the intercept is on button. So proxy intercept is on. Always make sure that this is off. There's very few instances where you want intercept to be on, and in those cases you need to manually switch it on. You can manually switch it to on. Make sure it's off, because I'll show you what happens if intercept is turned on. Okay, so over here, let's go to proxy intercept on. Okay, and then go over to your Burp Suite browser. Burp Suite browser. In here, we just, we want to put in another command. I don't know, ID. Click on submit, but nothing happens. And nothing happens because intercept is turned on. And when intercept is turned on, you need to go over to Burp Suite, and you're going to see this request over here inside of the proxy intercept. This shows you a request that we sent through the web browser. And we need to manually forward this or drop it. And we need to do this for each request that we send through the browser, or each request that is made by the browser. And if you don't know that this is on, you might start wondering what's wrong with Burp Suite, and you might start tearing out your hair trying to figure out why nothing is being sent to the Burp Suite browser or the proxy. You need to make sure that intercept is turned off every time you start browsing normally using the Burp Suite browser. I mean, people might think that I'm over exaggerating. You can lose hours. You can be very, very frustrated because you forget to turn intercept off. I'm pretty sure that intercept is off by default in most modern installations of Burp Suite, but you just need to be aware of this. Okay, let's move on. When intercept is on, each web request has to be manually allowed or dropped before the next one can be sent. In most cases, we don't want this, and we should ensure that the intercept button is toggled off. Okay, so the Burp Suite target tab allows us to define which IP addresses and/or URLs are considered in scope for web traffic proxy and capture. And most of the time, when we're doing testing, testing as beginners using Burp Suite, we don't need to worry too much about this. This is more something you need to worry about if you're doing professional testing, because when you're doing professional testing, you need to make sure that you're not doing testing against stuff that doesn't belong to your customer. Jason IT Solution says, true, or you can change your network settings in the Firefox browser to manual proxy. Yeah, that's the other way of using Burp Suite or using the Burp Suite proxy is to connect the Burp Suite proxy to your regular web browser. I think you can do it inside of the attack box here. So if we go over to attack box, inside the attack box, I'm going to start up the regular Firefox web browser. And the regular Firefox web browser, we can switch it over to be recorded by Burp Suite. But in order to do that, we need to close out our Burp Suite browser, because it's usually either or, because they share a port. Of course, you could make it so that the Burp Suite browser and the proxy use a different port, but you can click on Foxy Proxy over here, and in Foxy Proxy, it's a proxy service that's going to proxy all of the traffic from the web browser over to a specific port. And in this case, we've got it configured for Burp Suite. This is gonna I'm not, most of the time I don't deal with this. I don't deal with regular web browsers being connected to Burp Suite because I don't think it's necessary. Of course, if you want to, you can set it up that way. But setting it up is a bit of a pain in the butt, so I generally don't mess with it. Okay, so where were we? Oh, you know what? I'm going to switch my Foxy Proxy off. Otherwise, it could interfere with some stuff. Okay, so let's go back. So yeah, sitemap and issue definitions. Most of the time we don't need to worry about this. You can set it so that you're only recording traffic from specific IP addresses or domains. And that comes in handy when you're doing professional work. Burp Suite browser, we talked about this. Using the Burp Suite browser to proxy web traffic is the more convenient option over using regular web browser proxies. So I'll demonstrate how to open up the Burp browser one more time. So in here, Burp browser is up. We will close it. Then we will go over to Burp Suite. We will go to proxy, and once we clicked on proxy, we can go over here on the right hand side of the screen, open browser. Okay. And let me grab that IP address one more time. Here. We can just paste in here, huh? Wow. That's very convenient. Okay, so we're going to log in again using admin and password. Okay. Grandplay says, please pray, Mr. Frog. What is this? Academy Binary Gecko? I don't know. Let me take a look at this. How are you, Gruntplay? Binary Gecko is it's some sort of cybersecurity education thing in Argentina. Okay. Tired, not that okay, but fine okay. I hope you're doing all right. Grunplay is an aspiring pen tester. Have you found a job? You don't have to answer if you don't want to. I know that you were looking for a job. You've been looking for a job for a while now. German company. Okay. All right, no worries, no worries. Yeah, so what were you doing? Over here. Okay, Burp Suite browser. That does sound messy, Grunplay. Okay, so Burp Suite browser, it's under proxy, and then click on the open browser button. So the Burp Suite browser, well, in the attack box in particular, you need to click on the allow Burps browser to run without a sandbox button over here. Otherwise, it's not going to work. So if you're using this in Kali Linux, you don't need to worry about this particular setting. Scoping and targeting. In most cases, we want to set a scope for our testing and exclude all traffic that is outside the URL and IP address of that scope. This is something you can do, like I said, but most of the time when you're doing security exercises, you don't need to worry too much about this. Proxying HTTPS. One reason why it's preferable to use Burp's browser to proxy web traffic is because it avoids some setup steps such as downloading and configuring HTTPS certificates, which is something you're going to need to do if you want to connect Burp Suite to your regular web browser. Okay, so let's see. All right, so let's see if we can use Burp Suite to do like a challenge or two. All right, so in education, okay, so we're gonna do a challenge inside of the DVWA over here, and remember, you need to make sure that the DVWA security is set to something that's not impossible. So security level is currently impossible. We don't want that. Set it to low. Ooh. Click on submit. Okay, and then let's pretend we're doing SQL injection again. Okay, so we got SQL injection. We got a section over here, and oh, you know what? Here, I'll demonstrate why we want to use Burp Suite in some cases over just using the web browser. So there's some things in this case. Let's go over to DVWA security and set it to medium. So let's set this over to the medium level, and then we'll go into SQL injection. Okay, so here we've got user ID and we've got a drop-down menu. So normally you wouldn't be able to do SQL injection if you're doing it through the browser, because there's no injection point. We've just got this drop-down menu to submit over here, and it returns some database information. Wow, Denkyaka, that's pretty grim. That's a pretty grim job forecast. Okay, so we've got so there's no SQL injection point, but if we go over to Burp Suite, we can go over to the proxy HTTP history, and let's see if we can find the one for just a second. I need to why can't I pull on this window? Okay, we can go down to the bottom. Okay, so get down to the bottom over here. There's the post request for SQL vulnerabilities here. Click on that, and you're going to see that we actually sent some information that we can control here. So ID equals 2 and submit equals submit. So even though we can't see this information, that we can modify this information, inside of the web browser, we can do it from the proxy. So we can click on it, send it to the repeater, and then in the repeater here, we can modify the information that we're sending. So here we're going to do to and, I don't know, to union select. So union select, we're just going to put it here. Union select null, null, null. So basically this is the portion, this is the part where we're putting in our SQL injection payload. So we're doing it in the post request, which is usually not something that you can modify when you're using the web browser. Okay, and we'll send that. We'll see what comes back as the response. So this comes back as 200 okay. And we see that this is the correct number of columns for the union select. So union select null null, we get the first thing, and then we know that our injection is working. So if we go over to the request, then we can start crafting other payloads. So select null null. What we want to do is we want to figure out what DBMS is being used, because we don't know the system, and that's the first thing we want to do instead of SQL injection. That is to say, the point here isn't to do, to teach everybody about SQL injection. The point here is to illustrate that there's stuff that you can modify inside of Burp Suite that you wouldn't be able to modify if you're using something like a web browser, because the web browser doesn't really let you modify everything inside of your post requests, just whatever is inside of the web page. So let's see. So just really quick, I want to reference my own guide. Just a second. After school web stuff guides beginners SQL injection. Okay, so union SQL injection. We identified the injection point. We determined the number of columns for the union select. Now we're trying to identify the database management system. So we could sub out one of the columns with the version over here, and we'll just go back. So union select null version. Whoops, version. And we'll try sending this payload. So send this. In response, we get, yeah. Okay, so we were able to do the SQL injection and get the version here. 5561 Ubuntu, and I guess because this payload worked, we identified this as MySQL, MariaDB, PostgreSQL. So this is probably MySQL. And from here, what we need to do is determine the database names. We don't really need to determine the database names, but we're going to do, instead, we're going to determine the table names in the database. So from here, we can do, let's see, select table name from this one where table schema equals database. So I can just copy this payload here and provide it as the payload instead of version. Why doesn't this copy over? Just a second, everybody. Copy. I guess I'll paste this stuff in here. Okay. Paste in the payload. And this should, if this works, it should be able to get us all of the table names in the database. Send this. Okay, so we were able to get the different table names. So guest book and users. Yeah, Gruntplay. I hope you're able to get an offer get a good offer soon, because it sounds like a pretty rough time out there. Okay, so we've got I think we can end it off over here. If you've got any other questions about how to use Burp Suite, when you're using Burp Suite, most of the time you're dealing with the proxy tool or the repeater tool. So if you know how to access the proxy tool and the repeater tool, you're pretty good for doing most of your easy level, web app hacking challenges. So know how to use the proxy tool, know how to access HTTP history and get those different requests, and know how to send those over to the repeater. So to send them to the repeater, just right click, select the send to repeater option, and then you should be good. All right, let's talk about, let's go into our summary today. Let's review the web app hacking concepts we learned in today's workshop. So Burp Suite. Burp Suite is the industry standard software framework for testing web apps. It includes many different tools, but the Burp tool that enables the rest of the framework is the Burp proxy tool. So this is the tool that enables web app traffic to be captured and recorded. It sits between the browser and the server, enabling traffic capture. So what are we doing next time? Unfortunately, this is going to be the last session we're doing for web app hacking for this course, but we're going to be doing a next time and next week we're going to be doing a new course, and the course we're going to be doing is going to be for forensics. So digital forensics, and digital forensics has to do with inspecting files and other media for hidden information. So what are we going to be doing inside of our 8-session forensics course? We're going to be taking a look at picture files. We're going to be taking a look at the awesome thing that's called steganography, which is hiding information inside of different media files. We're going to be taking a look at network forensics, which is basically looking through packet capture files. We'll take a look at disk image files and how to look for information inside of those, as well as memory dump files. So that's going to be a lot of fun. And if you're into doing some digital detective work, then digital forensics might be the thing for you. All right, so let's go ahead and move into our next topic then. The next topic is going to be a demonstration. Just a second. I think I can get rid of this stuff over here. While we're switching topics, okay, I think we're done with our Try Hack Me stuff. Let me get rid of that. So if you're wondering where you access, if you're using Kali Linux and you're wondering how to access Burp Suite from Kali Linux, it's you just need to go over to Kali Linux up here. So from the start menu here, you can look up Burp, and you can click on Burp Suite from here. So that'll set up Burp Suite. The version of Burp Suite that's installed on these systems is the Community Edition, which is perfectly fine. Most of the time, not to say that the Community Edition can do everything. It is very limited, but most of the time you don't need to have the paid version of Burp Suite to do web app hacking exercises. Of course, it sure does help sometimes, but anyways, just like on the other version of Burp Suite that we were looking at, you can go over to the proxy. You can make sure that the intercept button is switched off, and you can go to the proxy, the repeater, all the other tools. Honestly, most of the time you're only using the most of the time I only use the proxy and the repeater tools. Anyways, let's move on to the next topic. And to do that, let me do a little bit of cleanup. So we got some tabs over here, great. And what we're going to be doing for the next thing, let me set that up. Topic 2 is done. Topic 3 is here. Topic 4 is on deck. Okay, so we're going to be doing one demonstration from PicoCTF. and we're going to be doing it for this challenge over here. If you're interested in trying out the challenge yourself, and you know a little bit about binary hacking, you might be able to solve it before we do. Jason IT Solution says Pro version is for enterprises. Not me. I can't dip in my buck. Well, I mean, if you're working inside of web app hacking as a job, then I think it is worth getting the license for Burt Pro. I'm pretty sure it goes for about $425 US for a year right now. But yeah, let me know. Let me know if you've got other information about that. Oh, it looks like my avatar froze. Okay, let me restart my avatar. It seems to be frozen. Just a second, everybody. Okay, so avatar is Okay, so the avatar's gone. Let me start up the avatar again. Okay, I should be reappearing in just a second. Here I am. There you go. Okay, okay. Great. And let's start up the music again, too. All right, so in order to do this, I need to grab my PDF file. We're going to be doing some binary hacking demonstrations. Let's see, this is from PicoCTF, and it's from the Pico Redpone challenge. If you're interested in taking a look at a walkthrough file that we're going to be following here, this is it. And let me grab the file for the PDF. Oh, can't edit that file, it's a binary file. Okay, so for this challenge, before we start the challenge, I'm going to set up my environment over at the PicoCTF web shell. If you want to, the great thing about PicoCTF is that they let you use the web shell, and the web shell is a virtual machine that has, well, it's a Linux virtual machine with all the tools that you need to solve most of these PicoCTF challenges installed in it already. And I really appreciate PicoCTF because they give people who don't have access to the who don't have access to hardware, like a computer that has Linux installed, they give them access to these kind of tools over here, which is very good for people who are just starting out. So let's see, this challenge is called Clutter Overflow, so I'll just make a directory called Clutter. We'll enter that directory, and okay, let's get started. Alright everybody, this is a guided walkthrough for the Clutter Overflow Challenge from PicoCTF as part of their Pico Mini by Redpone series. Alright, the description for the challenge says, clutter, clutter everywhere, but not a byte to use. Okay, they've got a command that we can use to access the binary that we need to hack for this challenge. And they also have two files that we can access over here to help us solve the challenge. So there's the C source code file, and there's an offline version of this binary that we need to investigate as well. So we're just going to highlight this over here, shell.c, and then select copy link. Copy link. After we've done that, we're going to go over to our web shell. In the web shell, what we can do is we can copy the challenge files using the wget command. So wget space, paste in the file address, hit enter, that'll download the file. So this is the C source code file. We also need the offline version of the file as well. We can hit up, and we can just delete the .c on this particular file name, and that'll download the offline binary. Okay? So after we've done that, before we can get started by, testing out the binary, we need to make this executable. So we can do that with the chmod plus x command, chmod plus x shell, which is the name of the binary. And after that, we see that this file is now executable. Just so we know what we're dealing with, and as a point of reference for the future, we can run the robin2 binary, or we can use the robin2 tool to inspect the binary, because there's something that we're going to have to note right here. So robin I shell. Okay, this lets you know about all sorts of important information about the binary before we go into the challenge. So you see here that the architecture that's being used here is x86. It's a 64-bit binary, and it's an ELF binary, which is the standard type of binary for Linux operating systems. One thing that we have to note is that it uses little endian byte order, and this will come into play later on. So let's, with that out of the way, let's talk about what's going on in the challenge. So the other thing about what we have is we also have the source code that was used to create the binary. So shell.c, this is what is being used to compile the binary, and it's the stuff in the code that we need to figure out where the binary is vulnerable, and then we can do some hacking against it. So let me just demonstrate what the binary looks like when you run it. So we run this binary over here by referencing the directory /shell, and we've got a picture of a room. My room is so cluttered, what do you see? So we've got some user input here. We can just put in a bunch of A's. This is what we do for binary hacking challenges. After we do that, we see code equals 0, hex 0. Code is not hex deadbeef. So hex deadbeef is what we need to pay attention to here. If we can switch code, or this value over here, to hex deadbeef, then something good is going to happen. So let's talk about that. Okay, so this is Pico Mini by Redpone Clutter Overflow. This challenge is an example of a variable overwrite binary hacking challenge. So variable overwrite, what are we talking about? So in this little C snippet right here, if code is equal to goal, then write how did that happen, take a flag for your troubles, and then cat flag.txt. So the goal of the exercise is to actually make it so that this condition is true. So the value of code is equal to the value of goal. So according to the source code, if the code variable matches the goal value, then the flag.txt file contents are revealed to us. So it does a system cat flag.txt. So code is initially set to 0, and the goal value is hexadecimal dead beef. So the program doesn't give us a normal way to set the code variable, so we need to find a way to modify that value. So in the code we see code is defined as a long variable and set to 0. Dead beef is the value of the goal variable here, or the defined variable over here, goal. Okay, this is where the vulnerable C function comes into play. So in every one of these challenges, the reason why the binary is vulnerable is because it's using vulnerable functions, or vulnerable C functions in this case. So the binary uses the unsafe gets function to save user input to the clutter array with a maximum buffer size of hexadecimal 100 bytes, which is 256 in decimal notation. So the program uses the gets function, and that's the user input. The user input is going to be saved to the clutter parameter, or the clutter variable, and the buffer size, the memory size for this particular buffer is 256 bytes. So since the gets function doesn't check the size of the user input before writing it to memory, input in excess of 256 bytes will overflow into other memory addresses. So this would cause what is called a buffer overflow. The clutter variable is saved to the memory stack, and overflow here affects program execution. Overflow here to affect program execution is known as a stack buffer overflow attack. So when we talk about stack buffer overflows, we have to understand how memory is organized. So the memory stack is part of the program memory, which stores temporary data during program execution. So if these addresses over here are not really accurate to what is actually going on in the program memory, but we just want to illustrate that the addresses are going up in size, and most of the time the memory addresses are using some sort of hexadecimal number as the address. So the lower addresses are going to contain stuff like the program data, the initialized variables, and then the memory heap. So the memory heap is another type of memory that the program uses, but the memory that we're taking advantage of here is called the memory stack. So stack memory, or the memory stack. As the memory stack grows, it progresses towards lower addresses in program memory. So the stuff that is being put into the stack memory, it eventually works its way up towards the lower addresses here. So in the case of stack buffer overflow, it may be possible to overwrite other program values or other program variables, such as the code variable. So imagine we've got the code variable in the program memory at this address over here, and we've got the clutter variable at this address over here, and the stack is going, if the clutter variable is put on the stack, we could send a bunch of information to the clutter variable and have it eventually go up and overwrite the code variable over here. If the code variable is written to the memory stack before the clutter variable, then we could overflow data onto the stack to overwrite the code variable. So the first thing we need to do is we need to find the overflow offset. In any buffer overflow attack, we need to know how many bytes we need to send to the binary to reach the memory location where we want to overwrite. This number of bytes is called the offset. So we've got over here, clutter is set to the buffer size of size, and size is set to hexadecimal 100, which is 256. So we can create a pattern of characters to send to the binary to determine the offset value. Okay, so we'll demonstrate this right now. Okay, where are we for the web shell? So in the web shell, we've got the two programs. We've got the program here, shell, and if we run shell, we know that we need to send at least 256 characters. 256 characters. If we just do this, by eyeballing it, that's not really the way we want to do this. We want to do this in a more programmatic way, or in a more reliable way. Anyways, how can we do this? We can send a bunch of A's by using the Perl program, for instance. By using the Perl program, Perl is a scripting language. We can do Perl execute a command, print. Oh, let me take a look at my notes just a second. Okay, so Perl, we can print a bunch of A characters. Okay, So we give this Perl command to print a bunch of A characters. So for instance, let's have it print out 300 characters. We know we need to send characters in excess of 256 because that's the amount that's sent to the amount that's defined by the program. So if we try 300 A's, we can use this Perl command to print out 300 A's. And we can redirect this. We can pipe this out into the chal binary here, like this. So this is going to feed in all these A's into the program output, and we see that the code variable has been replaced. So it's been replaced with all these 41s. So this is not the number 41, this is hex 41. So hex 41 is an ASCII character. Denkiato asks, how do you know where in the stack the code variable data is stored? I mean, we know that the code variable it's initialized before the clutter variable, which means it's going to be somewhere above the clutter variable, and we know that the stack grows upwards. We don't know exactly where it is, and the way we figure it out is we need to first figure out how many characters is needed to overflow into the code variable here. So we see that at least 300 is enough to overflow into the code variable, but we can actually create a more reliable method to figure out what exactly the offset is. So we run rag2, and rag2 is a part of the Radare suite, which is installed on the web shell here. So let's see. We're going to print out 300 characters, and this is going to create a pattern that we can track. So it's an organized pattern of characters here. We're just going to copy all of this. And then we're going to echo this out. And we're going to pipe it into the chal binary here. So this is the pattern that was created with the rag2 tool. And we see that after it's done, the code variable is filled with this information here. So we can just copy this information, and then we can feed this as a argument to the rag2 tool again. But in this case, we're doing rag2, and we're going to query how many bytes have been recorded if this is what appears in our memory location. Okay, and it says little endian 264. So remember that when we inspected the binary earlier, it was reported that this was a little endian byte order binary. So this is 264, and this is the offset that we're going to be using. Okay, we got ads running on Twitch. Just a second, we'll take a little water break so that people don't need to miss anything. And you know what? Let's put on the rainy day birds. So it was a really rainy day over here, so I'll just put on this rainy day bird video. We'll be back in about 50 seconds, just need to take a little water break. Okay, let's put the birds away and let's get back to the hacking. Okay, so what did we just find out? We found out that the offset to enter into the code variable here is 264 characters. So if we know this, And we know that what we need to send into the code variable is this set of bytes over here, dead beef. Then we could craft a payload using Perl in order to do that. So before we get started, let's talk about what we're doing exactly. So we used the rag2 program to create the pattern, and then we fed the pattern into the binary, and then we saw that this value over here was in the code variable. We looked that up with the rag2 tool again, and it gave us the number of bytes for the offset. So once we know the offset, we can send the offset, then append the correct bytes to overwrite the code variable. So we use a Perl command here. Again, we print a bunch of A characters equal to the offset, and then we send some hex bytes. So these hex bytes are dead beef. So the data bytes that we need to send are hex dead beef, and each byte is 2 hex digits. So in this case, we send DE, AD, BE, and EF. So these aren't ASCII characters; these are hex bytes. So, but since the binary was compiled with little endian byte order, we need to feed in the bytes in reverse order, which means we need to feed in EF and then BE and then AD and then DE. So if we read this backwards, it's dead beef. Okay, so let's go ahead and do that. All right, so it's the same. It's the same Perl command we did before. We need to put in 264 as the offset, and then we need to feed in some hex bytes. So the hex bytes are going to be all /x/x/x/x/x. Oh, you know what? We need to create our flag before we do this, because the goal of the exercise is to read the flag, but there's no flag in here, so there's no flag.txt file. We're just going to make one. We're going to echo out and redirect to flag.txt. What's going to be the flag? HackerFrogs like and subscribe. Okay, so we got our flag. If we're able to read this message instead of flag.txt, we know that we've solved the binary. We've solved the binary exercise. Okay, so Perl. Sorry, grab that Perl command again. Okay, so send the offset 264, and then add on to that hex. It's DE, AD, BE, EF. So we need to send these in backwards because this is a little endian binary that we're dealing with. We run that, and then what do you see? Code equals dead beef. How did that happen? Take a flag for your troubles. HackerFrogs like and subscribe. So Denkiako says, I don't understand why it's in 2 bytes if the offset is 256 A characters and the goal variable needs to be equal to hex dead beef. Why not turn dead beef hex 2 characters and then append those 254 A characters, the ASCII representation of dead beef? I want you to look up the ASCII representation of dead beef. These are not printable ASCII characters. So I'm pretty sure that none of these characters are printable. So the reason why we're using Perl instead of using regular old ASCII characters is because hex DE is not printable. Hex AD is not printable. We can look this up right now. ASCII table, or actually hex to ASCII. Hex to ASCII. So if we do DE, hexadecimal to text, convert, nothing appears. Nothing appears because it's not a printable character. But if we send hex 41, this is the hex code for the A character. Why does this not show up? Oh, okay. So hex code numbers are drop file. Convert this. This is A. So 41 is A, but DE is this character. And this character isn't, well, it is a character. It is a printable character in this case, but it's not a printable character on my keyboard. My keyboard can't do this. Hack Smarter, hello, nice to see you here. Okay, so let's try like EF. So EF, we can convert this. This turns into, once again, it's a character I can't use on my keyboard. But how about AD? So AD, this one is yeah, this one is not a printable character. So I mean, even if we were able to get the printable characters, there's one character that's not printable, so we can't send this as regular ASCII characters to the binary. So this is why we use Perl. Okay, so we know what the correct payload is. And Hack Smarter, hey, if you didn't know, Hack Smarter, the bytes are up to 255 decimal. No worries, no worries, no worries, Dunkiago. It took me a while to figure this out as well, and I really tried to brute force whether or not we could send printable characters to these binaries before. Okay, so if you didn't know, Hack Smarter is a Twitch streamer and a YouTube content creator, and they recently started up their own education platform. What is the name of the? It's like Hack Smarter. Is it hacksmarter.io or .org? Hacksmarter.org. So if you're interested in supporting some independent InfoSec creators who are trying to build some really cool labs and stuff, then go ahead and check out Hack Smarter. Okay, so all right, so from here we figured out how to hack the offline binary here, but what we need to do to actually finish the challenge is to access the thing online, because we don't get the actual flag from the offline binary. So where's the challenge? Here? Okay, so they've got a netcat command that we can use to access the binary. So this is the service that's running the binary online, and it's the same thing. It's the exact same thing, only there's a slight twist. So we need to send the same payload, but we're not sending it to the local offline binary. We're instead going to pipe this into netcat. Ooh, that's not netcat. We're going to pipe this into netcat. Let me copy this again. I'm going to pipe this into netcat, and it should get us the flag. The problem is, it doesn't get us the flag. So I'm going to give everybody like a couple of moments to identify what's wrong with this payload and why it doesn't actually send, why this payload actually doesn't send to the netcat binary that exists online. So there's something missing. So the problem here is that the Perl payload, there's no line feed. So run says null. It's not exactly a null character that we're forgetting to send. We're forgetting to send a new line character that's going to terminate the string. So we can just add like the new line character onto the end of the payload. So it's hex 0a. This is the new line character in hex, and if we just append this to the end of the payload, then we're able to get our flag. So we got PicoCTF controlled clutter in my buffer. Okay, Just going to copy that. We can submit this to the challenge. And then we're done. Just a second, everybody. I need to take a little sip of water. My got something stuck in my throat. Okay, everybody, that was a guided walkthrough for the Clutter Overflow Challenge from PicoCTF as part of the Pico Mini by Redpone event. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. We're not leaving. That's just something I gotta say for the YouTube video. Thank you. Thank you very much for indulging me here. That took wow, that took 30 minutes. I didn't expect it to take 30 minutes. Anyways, yeah, so the cool thing about this particular challenge is that the challenge doesn't need us to use a debugger. I mean, we could use a debugger. We could, we could go in and we could debug the program. And actually, just for fun, because we got some extra time, let's go ahead and do that. Let's get our pattern first of all. So we'll get our pattern, this one over here, and we'll try feeding this into the binary while we're debugging it, and we'll see what happens. Okay, so if we want to debug this, I'll use my favorite debugging program, Radare2, in debug mode, and we'll run shell. Okay, so after we're in Radare now, we can analyze the binary. And after we've analyzed the binary, we can inspect the main function. If we wanted to, we could also just, there's only one function in the binary. There's just the main function. So we do print disassembly function at main. And these are all of the assembly instructions. And this lovely section right here is rendering out the ASCII art for the room. And what else do we have? What we want to do is we want to figure out where in the memory the code variable is saved to. Okay, so this code, let's go up here. So what we're interested in is, well, let's figure out what happens when we just run the thing first. So we run the binary with DC, and this is the regular output for the program. We can paste in our really, I accidentally copied something that I shouldn't have. Just a second. I mean this crashes the program, but instead of our usual stuff in the code variable here, it's all of these in here. So I think the underscores are 5F. I mean, we can double check that over here. 5F. Yeah, that's the underscore character. Okay, and so code, we need to figure out variable. So there's a variable. There are two variables that are saved in the binary here. So there's variable 110 hex and there's variable 8 hex. So I'm guessing that this is going to be for the clutter variable here. So we can actually take a look at what is in that memory location. We do px print hexadecimal at rbp minus 0x110. So all these variables are going to be saved behind the base pointer. So the base pointer is a memory register that references the bottom of the memory stack. And if we take a look at this, this is just filled with a bunch of these underscores. So hex 5F, or wait, Yeah, why did it disconnect me? Okay, so it disconnected me for some reason. Denkiato asks, how do you know which functions are vulnerable to overflowing? And how do you know that such a function was used if not given the source code? I mean, that's what, if we were not given the source code, then you would have to do some trial and error. Most of the time, it's going to be one of, let's go into the clutter directory. Most of the time it's going to be well, we're dealing with C, and C has a number of different well-known vulnerable functions. So the vulnerable function that we're dealing with in this case is the gets function. So gets is a C function that takes in user input, but it doesn't. It's unsafe. It's unsafe because it doesn't check that whatever it's saving is smaller than whatever it's saving to. So it saves to the clutter variable, and the clutter variable is defined by size, and size is hex 100, which is 256. It's basically the ability to identify the vulnerable functions. So a couple of vulnerable C functions that we see pretty often in these kind of challenges are the gets function and the string copy function. So let me hold on. So there's the gets function and there's the string copy function. The gets function, it takes in user input, and the string copy function, it copies values from one location to another. And these are usually the culprits in a lot of these beginner level binary hacking challenges. Okay, Denkyo asks, is string compare also vulnerable? String compare, I don't think so. But I mean, you can, if you want to learn more about binary hacking with C binaries, there's a big list of, let's see, memory unsafe C functions. So unsafe C functions and their replacements, sure. So gets replaced by fgets, sprint is replaced by we don't know. String copy is replaced by string copy with an n, and etc. etc. No worries, no worries. I'm learning this stuff as well. I'm learning by teaching, and if people spot anything wrong with anything that I'm talking about, please point it out, because I don't want to be wrong, and I don't want to spread inaccurate information. But yeah, most of the time you look out for the vulnerable functions, stuff like string copy, stuff like gets. And your other question, Denkiato, was what happens if you don't have the source code? If you don't have the source code, then you just do some experimentations. Like, I mean, we could probably guess this challenge in particular. It's pretty transparent as to what it's doing. So if you just run the challenge by itself, we know that most of the time when we do buffer overflow attacks, we need to send a bunch of information to some buffer. In most of the cases, it's going to be some sort of user input. So in this case, it tells us that it's looking for some sort of value in the code, and the code is supposed to be this. We run it again, and just for fun, let's just copy this. We just want to send like a bunch of stuff to the buffer until it crashes. So we see here that we've got segmentation fault, which means that the program crashed, usually because we overflowed the buffer. And in this case, the code is filled with a bunch of these 22s. So 22 is probably the ASCII hexadecimal code for these double quotes here. So if that's the case, we need to figure out what we're going to figure out what the offset is, just like we did before. We just need to figure out how many characters it takes to crash the program. And in this case, it tells us that we're dealing with the code variable, and we've got something to compare it with, which is hex deadbeef. So yeah. What else were we doing? Oh yeah, I think we were also trying to figure out what the offset is. Just a second. And the code is 8 bytes long because it's long. Yeah. So the different C variables. So it's a long is an integer. I'm pretty sure. Cat shell.c. Let's see. Long. Where is it? What? Why did you disconnect me again? Integer stores 4. Yeah, the data type that's being used in this case. All right. Sure doesn't. Okay, where's that long thing defined? Long code equals 0. Yeah, so that's right here. Why is it saying core dumped? It says core dumped. That's part of the what is it called? The crash message. That's usually what happens when you have a memory segmentation violation. So a seg fault. A seg fault is a type of crash. The type of memory crash where it's the type of memory crash that happens when the program tries to access illegal memory. So illegal memory says segmentation fault. This is the type of crash. Core dumped. So core dumped specifically. Let me look that up. Binary crash. Core dumped. The program has terminated abnormally, and the operating system has created a core dump file. The file is a snapshot of the program's memory and state at the time of the crash. Okay, so the operating system, in response to the crash, has saved the program's memory image to a file on the disk. So typically named core. I mean, this isn't something I've investigated before, but thank you very much for letting me know about this. So where do we find this? So where is the core dump? Okay, so this prompts another question. Linux core dump file location. Okay, so var lib systemd core dump. Is this in here? Let's check. Let's investigate. There is nothing here. I mean, it says that the core was dumped, but it doesn't create a core dump file. You know, the funny thing is that there's some sort of data in here, because it says that there's 6 bytes. But I don't see anything in here. Is that just the folder itself is 6 bytes? Not sure. Okay. Anyways, we were also investigating, what was it? Okay, let's just grab a bunch of let's just grab a bunch of A's so that we can feed it into the program. So just a bunch of A's. Might be hidden. I mean, we should be able to see hidden information. We should be able to see hidden information while we're when we do LSLA. Okay, so R2 D shall. Okay, so what I'm going to do here is I'm going to see if I can locate the initialization of the core and the clutter. Clutter is not going to be initialized, but I'm going to see if I can locate the core variable. So print disassembly function at main, and okay, so which one is okay, this is it over here. So the initialization is going to be at var hex or var 8 hex over here. Okay, so I'm just going to copy this address here. I'm going to set a breakpoint. So the breakpoint is right after this variable is set up in the memory. We're going to set a breakpoint like this. So db, then the memory address, run the program, and then it hits the breakpoint. After it hits the breakpoint, we can take a look at the variables. So there's two variables in the program. So AFE brings up variables. There's one at RBP minus hex 8, and one over here for RBP hex 110. So this is the one for clutter, and this is the one for code. So if we take a look at the contents of this, so print hex at this, we see that it's been set to 0 over here. So this is, yeah. So it's set to 0 right now. And what we need to do is we need to take a look at this after we overflow the buffer. So we overflow the buffer. Hold on, let me get some output. So rag2, print out 260. We know that the offset is 264. Let's do 265. So 265. And if this is successful, then there should be the small letter b in the core variable afterwards. Okay, let's go back. We run the program. We put in the pattern here. And then we see that in code, there's 62. So 62 is the small b, or at least I think so. Let me double check that. So 62, small b. So how else can we confirm this? So we can also confirm this by taking a look at, by setting another breakpoint. Here, this is what we're going to do. So the other breakpoint that we're going to set is right after our user input. So where's our user input? Let's see, system. It's gets. So this is the call to gets right here. And we just need to set a breakpoint for right after we do our user input. Okay, we set a breakpoint there. And then let me grab my pattern so that we can feed this in. Okay, run the thing. Whoops. Something went on. Something's wrong. For some reason, the breakpoints aren't running. Uh-oh, I think I disconnected from my web shell. All right, let's reload this thing. Okay, we'll run Radar 2 again. Okay, so we just need to set the breakpoint. Oh, we need to analyze it first. So before we analyze it, we don't even identify where the main function is. Okay, so we're going to set a breakpoint right after the gets system call, which records our user input. So I'm just going to grab this memory address here. I'm going to set the breakpoint, and then we're going to run the program. Okay, so we'll grab the pattern, paste it in, and then we hit the breakpoint. So remember that the variable for code is at RBP minus hex 8. So we're just going to print the hexadecimal, or PX, here, and there's exactly the character B inside of the code variable. So this is how we would identify this kind of stuff if we didn't have the source code. So if we didn't have the source code, we'd have to do a lot more guessing, or trial and error stuff. Most of the time, binary hacking challenges give you the source code so that you don't have to spend a lot of time reverse engineering the binary, and you spend more time trying to figure out what the actual binary hacking solution is. But anyways, let's get out of here. I highly recommend taking a look at some of the other binary hacking challenges. We've done a number of demonstrations already. You can find them on my YouTube. Where is it? So go over to, well, I mean, you can just search the channel here for binary. You should be able to see. Hold on, I think I've got a playlist. Do I have a playlist for binary hacking challenges? I do, okay. So we got these ones over here. Thank you very much for following on YouTube. Aman Babu, thank you. Welcome to the HackerFrogs. Okay, we're going to be switching over into the new topic now, because, well, we're going to be doing more binary hacking stuff, but this time it's stuff that we haven't seen before, so good luck to us. So it's going to be over at training.OLIcyber.it. This is a very good website. I think it's next to PicoCTF. It's my favorite. It's my favorite cybersecurity education platform for learning about cybersecurity through CTF challenges. So the only wrinkle in this website is that it's in Italian. If you can read Italian, that's great, but if you can't read Italian, you can translate everything. You can just go over here, go to translate page on your Firefox or your Google Chrome or whatever. Do you have a cheat sheet for the tools and commands used? Jason IT Solution says binary hacking is stiff. For me, dyslexia. No worries, no worries. You know, if you don't do these challenges over and over again, it's hard to get a feel for them. Okay, so we're going to translate from Italian to English. Translate. Isn't the internet wonderful? Okay, so you can go over to challenges, and let me tell you, OLIcyber, the introduction challenges, they do a very good job. They do a very good job of explaining the concepts in each one of the categories. So you got miscellaneous category, network security, web security, cryptography, software, and I've worked through. Well, I want to work for the rest of these introductory challenges. They're very, very good. Repetition is the true teacher. It's 2Bob. Hello, nice to see you here. You caught us just in time for us to maybe not solve some binary hacking challenges. So yeah, welcome to the stream. and hope you're having a good night. Okay, so let's go ahead and start our timer. We'll do 90 minutes, and we'll see where we are after 90 minutes. Okay, so topic 3 is done. Topic 4 is here. Okay, so what we're trying to do, for these challenges here is we're trying to these challenges here. They're trying to teach us how to use the Pwn Tools Python library to solve challenges. If you get deep into learning about binary hacking, you usually need to use some sort of script to help you work through the challenges. It helps you do complicated things like find ROP chains or other gadgets that we can use to abuse the binaries. Okay, so if you're interested in doing this exact challenge, you're going to need to access this particular page, and let me see if I can get... Okay, so if you want to mess around with the binary yourself, I think you can use my link. This is the link for the binary here, so it's software binary challenge number 19. And you can connect to the remote service with this command. I'm pretty sure you don't need to be logged in to use the netcat command either. Okay, so let me just copy this. I'm going to be doing my write-up as I'm solving this challenge, because documentation is very important. Okay, so where are we? So HackerFrogs, we record all of our walkthroughs, and I think we got something like 200 of them or something at this point for all of the different challenges that we've done. So OLIcyber, software hacking, software 17. Did we... Wait. Am I doing the wrong challenge? Because I'm currently doing 19. Oh, should I be... Maybe I should be doing software challenge number 18. Hold on. Just a second, everybody. I want to check to see if I've done this challenge before. Okay. All right. So I think I did this challenge offline, software challenge number 18, and I think I came up with a script for it. Let me take a look at the GitHub. Software 17, Pwn Tools 1. Did I forget? Did I forget to save my... Did I forget to save my GitHub walkthrough? Oh, that's really bad. Denkiak says, like, you got the flag, but it wouldn't accept it. Yeah, the last one, right. I forgot to save my write-up. I'm so disappointed in myself. Yeah, so we did number 18, so we should be doing number 19 now. Okay. So this is the one where... No, this is... I remember this challenge now. It was basically a challenge to do 100 different packings and unpackings for bytes, but it was intended to be accessed from Italy, because the server lag made it so that I wasn't able to complete the challenge. But anyways, let's do number 19. Okay, software challenge 19, Pwn Tools 3. Okay, let's start the write-up. Okay, software Pwn Tools 3 dot markdown. We're going to make sure to save our file this time. Okay, we need to record the URL of the challenge, the concept of the challenge, and the method of solving the challenge. Jason IT Solution says it's chilly, freezing in South Africa. Wait, is South Africa in the southern hemisphere or the northern hemisphere? So I mean, I'm in the northern hemisphere, but is it the summer in the southern hemisphere? It should be spring right now. I mean, I don't know. My geography is horrible. Let me know, Jason IT Solution. Okay, so the URL is here. The concept is, what is the concept? Pwn tools also allows you to interact with local binaries. The function can be used process returning an object as remote. It is often appropriate to have a script that allows you to choose whether to launch the local binary or to connect to the remote server. Okay? It's summer. Oh, it is summer right now. Okay, but it's still chilly. Huh. Okay, the following code snippet can be useful in these cases. So it's from pwn import star. Okay? Executable equals elf chal if args.remote, then k. Otherwise, something. The function elf allows you to load elf binaries and get different information. exe.sim returns a dictionary of elements, something in Italian. Okay. exe.sim.main or exe.sim.main returns the address of the main function within the track. The track of this challenge will ask you for the address of some functions inside of it. You will be provided the binary running on the remote server. Okay? You can connect to the remote service with this command. Alright, so let me download this binary here. wget, ooh, just a second. I should probably create a new directory to work inside of here. Mech directory, software 19. Okay, now we're going to download the binary. That doesn't seem like it downloaded what we wanted to. Okay, let's just download it the regular way. Click download. We can move it over here. Move downloads. Okay, so it's here. We need to make it. Is it executable already? It's not. Okay, make it executable. And they don't give us any. They don't give us any source code. You can connect to the remote service with this command. Okay, so let's go ahead and grab the snippet that they want us to use. And we'll start doing coding over here. So our Python code will be on this side, and then we'll start up a new to view 19. Denkiako says, was that a JSON token in the URL? I think someone could log into your account by pasting in cookies. I think someone could log into your account by pasting into the cookies? Well, I mean, if that's the case, I want to log out immediately. So just a second, everybody. I'm just gonna make sure that my cookies don't work anymore. Okay, so I just need to log out, and if this is a properly If this is a properly coded application, it should destroy the cookie, or it should make it invalid. Okay, let's try logging in again. Alright, so the cookie should not be valid anymore. Okay, so this is, let me grab this. And we need to translate the page again. Just let me do that. Translate page from Italian to English. Okay, so we're just gonna make a Python file. We're just gonna call it sw19.py. Or we'll do it like this. Okay, so from pwn import everything, exe equals elf shell. Well, I mean, it's not shell in this case, it's sw19. Okay, so I want to make sure that I've got the pwn, or the pwn tools module installed on Python. Just gonna start up Python. Import pwn. Okay, yeah, so it works. So I've got it installed here. Okay, great. Just a second. Need to. So if args.remote p equals remote host 1234 and process exe path. Process exe path. Exe path is exe.path. So I just need to grab my host name and my port number. So my host name is this. The port number is 13002. 13002. This is... Okay, so what does the challenge want us to do? Ask you for the address of some functions inside of it. Ask you for the address of some functions inside of it. You will also be provided the binary running on the remote server. Okay, so I mean, let's just run the binary. Okay, this is where this is where it would be very useful to be able to read Italian. Let's go ahead and translate this. So this time it's Italian. Welcome to the third Pwn Tools Challenge. You will receive a list of function names and you must return their address within the binary in hexadecimal. If you're fast enough, you'll get the flag. You must complete 20 steps in 10 seconds. Send any character you get started. So you'll receive a list of function names. You must return their address within the binary in hexadecimal. Okay? So beef. So it wants to know, it's looking for the address of the binary in hexadecimal. Okay, so what's gonna... So it's looking for the beef binary, or the beef function, and... Okay, so... Here what we need to do is we need to get the output from the binary. Let me take a look at another script that we wrote for the previous level to see what's going on. I kind of forget how to use Pwn Tools. If I want to become good at doing binary hacking, I need to learn how to use pwn tools. I'm still learning right now. So let's see. OLIcyber, software hacking, pwn tools. We finished the first one here. Okay, import the pwn tools library, host and port, connect to the server. So let's see, r equals remote, host port. Then we defined a couple of functions, add numbers, receive isolated number lists, send answer. Okay, so I think there was a guide. So pwn tools, beginner's guide. Tutorials for getting started with pwn tools. Sharp pwn tools, let's see. A beginner's guide to pwn tools. I think I was looking at this before. Anybody who's wondering what we're looking at, this is what we're looking at here. Okay, so how to install, connect to a server or process. Well, running, the first target is to connect to the remote server. Okay. P equals remote, and P equals, what happens if we just want to connect to a local process? We write P equals process. Here's the catch, pwn tools doesn't know which process to connect to. Set the context.binary or provide argument. So we write, if the binary file name is shell, P equals process, and then give the file path, or context.binary equals .shell. Setting the context automatically tells pwn tools to run that specific binary. Okay. Or we can create an elf object and attach pwn tools to it. Okay, so setting our context or connecting to the remote server or attaching a process should be done at this moment. We're good to go. Setting up context.binary, creating elf object will be default, print the checksec results. Various protections apply applicable to binary. Shouldn't the binary run and show me output? Where's my output? It just talks about starting and ending the process. So what's actually happening is the binary is running, but we aren't receiving the output. So it's not showing up on standard out. Let's check if another functionality of the pwn tools. Okay, so we need to do p.receive, process.receive. Let's try this stuff that they mentioned up here first. So context.binary, p equals process. But what do we have in if args.remote? Okay, it's going to be this. Otherwise, p equals process executable path. So exe path, in this case, it's .sw19. Okay, so I mean, this is just the start of the script. And what do they mention up here? So they mention setting the context.binary equals binary equals elf chal. So if we set up the context, the funny thing is that it doesn't mention anything about printing out stuff to standard output. So if we set up the context over here, context.binary equals binary equals elf dot, well, sw19. What is elf? Elf is the standard format for executable binaries in Linux. So the ELF is an executable linkable format or something like that? Are you talking about else if? Or what are we talking about here? Okay, so if we just run the script, SW19. Yeah, okay. So this just gives us the information about the thing. And I guess this is prompted by context.binary. So stack canary found, NX enabled, NoPy stripped, debug info yes, and it just starts the local process and then ends the local process. That's fine. We just need to figure out how to do extra stuff now. Extensible linking format. Thank you too, Bob. Okay, so receiving output. So p.receive is equivalent to read, and we need to send like a number of bytes. Receives up to number of bytes from the tube and returns as soon as any quantity of data is available, right? Receive line, we took a look at the stuff in the first, the modern definition. You talking about executable linking format or something else? I get terms wrong all the time, but ELF binary. Let's look it up just for fun. ELF binary Linux. Execute and linkable format. Oh, okay. Right. Extensible linking format. I think. Are they both correct, or does one refer to a specific type like that was used in the past? I'm not sure. Okay, so let's go back to the article. Let me start shutting down some of these windows that we're not using right now. I hate having too many of these windows open. Here we go. Okay, so p.receive line, p.receive all, receives data until an EOF is reached and closes the tube. Be aware that receive all might be slow in receiving packets over the network, and p.receive until. Okay, well, I mean, we could do p.receive all, and then we just print it out and see if this gives us any meaningful output. I think I'll comment out this context binary stuff because we don't necessarily need this kind of output. All right, let's take a little break because we got ads running on Twitch. And we'll put on the birds. How about these birds having a snack? Where are we? Come out, bird. Okay. All right, we'll be back in about 60 seconds. Enjoy the birds and the music. I don't know about you, but there's something so gratifying about watching animals eating. You know, it makes you feel like they're having a good time. Oh, you know what, too, Bob? I remember you talking about what was it, American robins. So let me show you a video of an American robin. Hold on, where are we? So here's an American robin. Where is it? Here it is. Okay. And I can't believe you said that these guys were scary. These guys are adorable. I guess they are bigger than some of the other birds, but they are... I really like American robins. Look at that silly face. Okay, let's put the birds away. Let's get back to the binary hacking. Okay, print receive all. Let's save that out. Let's run the process, see what comes out. Until they start eating you. Are you talking about the robins? I don't know if robins eat people. Receiving all data, 501 bytes. Wait, why did... I commented this out. Why did it... Starting local process, receiving all data. Wow, this really is taking a long time. C. Calandro says, no, it's satisfying watching animal eat. Oh, okay. Well, I mean, I guess so. I guess it's satisfying watching them eat until they're eating you. Thank you for letting me know specifically what you're talking about. Okay, so, receive all doesn't seem to have gone over very well over there. Starting process, stopping process. So what is it that... Yeah, it just says starting process, stopping process. So this is the message here. Maybe just receive line. Okay. Let's just do... We'll start the first part. Okay, so receive until is the equivalent of read until. Receive data until one of the delims is encountered. Oh, hold on. Let me change up the music. Pran Kumar says, hello, sir, over and over again. You need to stop spamming the chat. Prem Kumar, welcome to the chat. Don't spam the chat, thank you. All right, so let's play this. Let's play this music playlist. Okay, so we can do receive and receive all. Let's do p receive for 4096. We'll see what happens. And I guess we'll print it out as well. If we don't print it out, does it still print? Yeah, it doesn't print. It doesn't print unless we specifically print it, so let's print it. Okay, so we received this stuff over here, and we know from running the thing ourselves that this is the end of the input here. So we need to receive until this. Okay, so we're gonna split this up into steps. So the first step is receive the initial message. Let's see. Initial message is going to be p receive until a string, and the string is going to be this one here. Prem Kumar asks, "Sir, where are you?" I'm located near Vancouver, Canada, British Columbia. Yeah, it's any more specific than that I can't say, but yeah, Canada, West Coast Canada. Okay, so we'll receive until that. Oops. Okay, so there's no receive until. Oh, did I misspell it? Yeah, I did misspell it. Okay, so okay, so we ran the thing. We just need to print the message. Receive the initial message, print it out. Init message. So this is what I like about iterative programming. We basically do it one step at a time, and we figure out if that step works. If it works, we can move on to the next thing. Okay, so here we need to send the first send confirm input. Prem asks, "I want to become a black hat hacker, but how?" I can't help you become a black hat hacker. We don't condone criminal activities on this channel. I can teach you how to do hacking stuff, but I can't teach you specifically how to become a criminal, because we don't do criminal stuff. I don't get it. You're in a cyber stream. You want to tell people where you're from. I mean, I'm a public person in the Vancouver cybersecurity scene. So if you really want to find out who I am, you could probably do some OSINT to find out. But I'm not super private about. Well, I won't tell you my exact address, but you know whereabouts I am. That's not such a big problem. And thank you very much for the emote Belmung. Sorry I didn't catch your message earlier. Okay, so we're running. So we have to send the confirmation input. It's basically, let's see, I think it's .send something, right? Or send line. Send stuff as bytes, sending a payload. So p.send payload or p.sendLine payload. We can just do p.sendLine, and we just need to send like so we're going to call this initial send equals p.sendLine I mean, I guess we don't need to turn this into a variable if we don't need to. We just want your mother's maiden name and no big deal. Sarcasm. Is compulsory programming for hacking? Tell me. Listen. Anybody can learn here. Just don't tell me that you're going to be using it to do criminal stuff. If I get a sense that you're actually doing criminal stuff, I'm gonna have to ban you from the channel. But anybody can learn here. Just don't talk about doing criminal activities. Initial send p.sendLine this thing. Maybe we'll just do p.sendLine, and then we'll receive the next thing. Receive the next. Receive message 2. So that's p dot message 2 equals p dot receive, I don't know, 4096. Oh, hey, Sick in the Mind. Hello, nice to see you here. Dankyoko says, can you even ban people on YouTube? Yeah, I can certainly ban people on YouTube. Prem Kumar says, can you speak in Hindi? I mean, I'm pretty sure you can switch the audio language over to Hindi on any of my videos. That doesn't work with live stream stuff. Brian says he's a troll. He's a troll. I mean, if he's actually a troll, then yeah, we're gonna have to ban him. But yeah. All right, let's so message 2. Let's save that and let's print it out. Receive message number 2. Print message 2. Listen, let's not be let's not be mean to anybody in chat if we don't need to. All we need to do is, all we need to do is have a civilized conversation. We'll ban people if we need to, but no need to be unkind. Second Mind says, gonna lurk for a few before I have to actually get to sit down here. Lurk for a few, focus on learning. Second Mind, well, I'm, whatever works for you is fine. Okay, print message 2. So send line this, and then we got here. So Bebe. So Bebe is, well, we need to save this. Okay, so message 2, we got some bytes. So we receive until, because it looks like the end of the output here is the colon. So message 2, receive until the colon character. Okay, then we need to find a way to turn this into a function, because we need to do this like 20 times. Like 20 steps in 10 seconds. That's what the thing wants from us. Okay, so yeah. So I mean, this seems to work. All we need to do now is we need to start saving. Well, we need to start saving what we receive as a variable name. So save the or extract. We're going to extract the function name from the output. Okay, so in this case, we received bytes. So everything between the space and the colon is the name of the function. So we need to figure that out. I know that's why I'd rather just not say anything. Yeah, listen. Let's be as kind as we can be. If there are actually people in here, who want to talk about criminal stuff, then we'll just ban them. And we can just do the function name message 11 or message 1 2 -2. Yeah, I think so. what we can do is we can just turn the, so we turn the output into a list. Actually, we need to make it, these are bytes. We need to convert this into a string. Convert the string, converts the bytes to string. Because, yeah, we can't do this directly from bytes. So that's going to be message to string equals message to dot encode, or is it decode or is it encode? Decode to UTF-8. And I guess we can print it as well. Print message to string. String indexing is also supported. String indexing is also, you don't need to turn it into a list. Do we not need to turn it into a list? Denkiako says message to 1, 1 or message to 1 minus 2. Okay, let me give it a try, Denkiato. Or message to, and we'll call this function equals one minus 1. No, it's not minus 1. It should be. Let's try printing it out. See what comes out. Message to function. Okay, so minus 1 gives us this portion right here. I think I would rather turn this into Prem asks, your teaching is the best. I don't understand. What are you doing? So we're just we're working on an exercise over at the OLIcyber website over here. So this is it's a free website for learning about cybersecurity stuff, but it's in Italian. But I think it's really good for teaching people about cybersecurity concepts. So if you can register for the website, and if you can use your web browser to translate it from Italian to whatever language you like, I think it would be really good for learning this kind of stuff. Let's go back. Okay, so what do we get there? We got cafe. We need to, I think we do need to turn this into a list, because we've got the yeah, well, we'll try turning into a list first. Convert the bytes to string. Message to string equals message to dot encode, decode. UTF-8, then we'll try printing that out. Okay, so this turns it into a string. If it's after it's turned into a string, then we can turn it into a list. Convert the string to a list. Message to list. It's dot split, right? I'm pretty sure that the name of the function we're looking for is dot split. And we can split this by spaces, which is the default anyways. And then print it out. message to list. A bytes-like object is required, not a string. What? Oh, message to string. Okay. Okay. Sure is fun to do some programming. Okay, so we got 2 things in the list. So we need to select this first, and then we need to chop off. We need to chop off the last character here. All right, convert the thing to a list. Extract the function name from the output is going to be function name equals message to list number 2. What was it? Item 2, and then we'll call this function name raw, then function name equals function name raw, and we need to get everything from it except for the last character. So start at 0, end at -1. Hold on. Print function name. 0, -1. Oh, right. You don't use a comma. You use a colon. Print function name. Okay, foo, and then foo. Yeah, okay, this works. This is correct. Okay, so we got the function name. After we got the function name, then we need to... Hold on. After we've got the function name, we need to look it up. So it's asking us to do what? You receive a list of function names and you must return their address within the binary in hexadecimal. So return their address within the binary in hexadecimal. Okay. So we need to find out Pwn tools function name lookup. Pwn tools offers several ways to look up function names and their corresponding addresses within ELF binaries, both locally and remotely. Okay, so local ELF binaries, look up the address of the function by its name. Function address equals elf.symbols function name. Okay, let's give this a go. Look up the function name's address. So function address equals elf.symbols. Did we define elf? We just need to make sure that elf is defined, right? Okay, elf.symbols function name. So the function name we're going to, well, function name is already up here. Great. And then we're going to print the function address. NE, hello, nice to see you here. Welcome to the stream. And you know what we haven't done a lot of in the stream? We haven't done a lot of this. Hack the planet.
Hack the planet! Hack the planet! Shut up and get...
Okay. Alright. No attribute symbols. Pwnlib.elf has no attribute symbols. Pwnlib.elf has no attribute symbols. What happened here? It's from pwn import everything. We're doing elf.symbols. No attribute symbols. Hold on. Did this thing hallucinate on me or what? Command line tools. Is there a way to use pwn tools to find the address? Okay, let's do Stack Overflow. It's more likely to be correct. Elf.symbols. It's the same thing. Okay, so elf equals elf path to your executable. I guess we need to define this. I see you're using Nano. Why don't you use Vim? The reason why I don't use Vim is because I'm not very comfortable using Vim. And Nano works for me. Most of the time I'm not doing anything super complicated. So most of the time the advanced stuff inside of Vim doesn't really apply to what I'm doing. You're like me 3 months ago then. Oh, okay. I mean, listen, if you enjoy using Vim, that's great. If you enjoy using Emacs, that's great. If you like using NeoVim, that's great. Okay, so elf.symbols function name. What am I doing wrong here? Print the function name. Great. Oh, this doesn't work because this is a this doesn't work because this is a string. Personal preference. Yeah, I mean, I respect your personal preference. You can use whatever operating system you like. You can use whatever text editor you like. You can use whatever favorite, I don't know, you can have your own favorite color, that's fine. As long as you're not, you know, forcing people to agree with you. Okay, so yeah, it looks like we got the, what is this? This is hexadecimal, or what is this? You can look up the address of the function by its function name. So the function name is, what was returned here? Was this, this can't be decimal, can it? Okay, so you return a list of function names and must return their address within the binary in hexadecimal. If you're fast enough, you get the flag. And he says, I think when you have time, you should learn some simple things in Vim. I used to not really like Vim too, but I learned to use it because it's kind of better than Nano, not gonna lie. I mean, I don't feel like there's anything in Nano that I don't feel like there's anything that I need more of than just Nano. All I need is the Nano stuff. I just need to be able to, you know, edit something very simply. And I don't feel like pressing I to go into insert mode and then pressing escape to exit from insert mode. The only thing I really know how to use in Vim is how I know how to quit out of Vim, and that's the most important thing to know. Okay, so function address, print out the function's address. It wants this in hexadecimal, and I wonder if this is just... It's not about feeling, but about addiction. Are you addicted to Vim? I don't think you should be addicted to a text editor. Okay, so this is... Let's just try running this a couple of more times. Okay, we got code. Aman Babu, are you also addicted to Vim? I mean, I guess I could say that I'm addicted to Nano because, you know, it's Nano is the only text editor I use. Is that the definition of addiction? So we need to convert, I mean, we need to convert this into a hexadecimal number. So we need to convert this number. Okay, so it's elf.symbols function name. I wanna look up whether or not this is supposed to be decimal or hexadecimal. You can also use A to insert after instead of using I to insert before. I'm using A all the time. Use hex function address 2. Just a second. I just want to confirm if this is actually supposed to be. Okay, if I'm using Pwn tools to run this code, is the result a decimal number or a hexadecimal number? I just want to confirm. Sure is thinking. Hats off to you for trying to solve binary hacking. This is going to be very slow going because I'm not. Yeah, I'm not. I'm not very good. I'm not very good at binary hacking stuff. Hold on. Okay, so it didn't run the thing. Let's try it again. I hate binary hacking. Well, hate's a strong word. The result is a decimal number. I've never seen memory, memory addresses described as decimal numbers before. This is why, I mean, this is why I had to do a double take, because every single time I've encountered memory addresses, they've always been hexadecimal. Okay, convert the function address to hexadecimal. Okay, so Aman suggests hex addy equals hex of function address Let me try printing it out. Okay, I need to spell everything correctly. Remember, everybody, you don't spell correctly, you don't get to hack. Okay, so I mean, let me just double check that this is what I want. And go over and use like a web app to do the translation. Decimal to hex. Decimal to hex, convert 40E8. Yeah, okay, that seems to be working. Great. And then we just need to send this, right? What do they want? Must return their address within the binary in hexadecimal. If you're fast enough, you'll get the flag. You must complete 20 steps in 10 seconds. Okay, so we've got the appropriate hexadecimal. We just need to send this. Send the hex address. And that's going to be, what is it called? P.send something, right? P.send P.send hexaddy. So after we send it, well, I think we don't need send line in this case. Send the hex address and then receive the next function name. Okay, that's going to be message 3. Message 3 equals p.receive. And we're just going to take in a bunch of stuff, and then we're going to read it. So once we confirm that this works, that we can send something off and then receive the next thing, then we can turn this into a function. We can turn these into functions, and then we can run a for loop, or like we can run a for loop, and then we can solve the entire thing that way. Print, what was it? Message 3. Text is not bytes. Oh, okay. Okay, so we need to convert the thing to bytes before we send it off. So p.send has to be bytes. Okay. Convert the function address to hex, then the string into bytes. So we got the hex address, hex bytes, hexaddy bytes equals hexaddy dot encode from UTF-8. And then we're going to send hexaddy bytes. Okay, let's make sure this works. Okay, so we sent the hex address bytes, but it still gave us this warning. Bytes warning, text is not bytes. Oh, okay. That was for this. All right, so we sent the new line. We receive until this. We received Bebe. Where was our send the text bytes? Okay, so I'm going to print out a little message just so we know what's going on. Sending first answer. Okay. Sending first answer, and then we didn't receive anything? Okay, we sent the answer, and then nothing. Let's receive some more stuff. So it could be that we need to do a send line instead of just a send, because it's not responding. Yeah, we need to send a line. Okay, so p dot send line. And let's see if this works. Sending first answer. Still didn't work. We did send line. Oh, okay. Okay, we needed to receive until again, and receive until, like, you know, the next thing. Okay. All right, let's so send. We are supposed to do send line. We're supposed to do. We'll do receive until the colon. Okay. Yeah. Okay, so this, I mean, this works. Text is not bytes, assuming ASCII, no guarantees. So sending first answer, p.sendLine, text is not bytes. Hold on. But we turned it into bytes here. So why does it complain that we're not sending bytes? That's a bit confusing. Okay, so I think everything's working so far. We just need to repeat this 20 times. Receive until. Where? Oh, this needs to be bytes. Yeah, okay. I think I know what you're talking about. So bytes. Yeah, okay. You're right. You're right. Same thing here. Send line can be bytes. I guess send line also needs to be bytes. We just need to make sure that everything is bytes. Thank you very much for letting me know about that, Aman Babu. Okay, so we sent the first answer, then we get the next answer, which is code, and we need to turn this into a function now. So we just need to turn into a function, then a loop. And what is going on? What's up, buddy? At work, I watched for a few, follow, love, and support, got big Twitch streamers, got thousands of eyes on a stream, and also almost 2 million followers. He's helping streamers like you with organic strategy to gain real audience. You know, Twitch has flagged your account as a possible ban evader. So maybe I'll pass. Maybe I'll pass. Thank you. Thank you very much. Okay, so yeah, well, we need to turn these into functions. So what are these functions going to be? I think we'll define the functions down here. What do we call the functions? So we'll call, the first function we'll define is going to be receive function name. Yeah. So receive function name, this will take in what? I don't think it needs to take in any arguments here. So we're just let's see. we're just going to do this right here. So receive until the colon. We're just, I guess we'll just call this message. And what are we doing? Receive the message until the message, we convert the bytes to a string. And then convert it to a list. So we do the list conversion, and then we extract the function name from the output. So function name raw, and then function name raw, and then function name. And is that it? And then look up the function's address. I mean, should that be? No, I think this can all be part of the same thing. So we got the function name, and then look up the function name's address. I mean, I guess we could make this all one thing. We'll rename the function. We'll call it lookup function address, and we'll just make this all one thing. Okay, and then this. So this. Jason IT says, how good is Shopify in marketing campaigns or ads or... You're asking the wrong person. I don't know anything about Shopify. I don't know anything about marketing either. But elf.simple's function name, okay? And what we want to, the only thing we want to output from here is the bytes. So convert the function address to hex and then the string into bytes. So this stuff here. So all we need to do here is just return hexaddy bytes. Random, but copying and pasting the add. He even said AI says it's a scam. What? What are we talking about? Anyways, just, you know, yeah, I'm probably going to need to ban this person. Just so I don't receive more messages. Copy and pasting the ad, he said, AI says it's a scam. Yeah, anyways. Balmung, thank you. Thank you for letting us know about that. Alright, what are we doing? Return hex address bytes. Sorry, bad grammar. AI mentioned it was a scam. No worries, no worries. Okay, so this is one function. Just receive until this thing. And then we need to make another function, which is I don't know, what are we going to call this? send answer. So send answer takes in the bytes. Answer bytes. Shopify? Why are we talking about Shopify? Did the yeah, okay. Send answer bytes. This is going to be this portion right here. P send line. Hex address bytes. So I mean, it seems like ADDI bytes, answer bytes. And I guess we can also print out a little message as well. Print. Send answer bytes. Okay, so if we've got these two functions here, we can just create a loop out of this, and all we need to keep, well, I'm going to keep this this code here, just in case I need to reference it later. But I think all we need to do is use these two functions here. So the only thing we need to do, the only thing we need to keep from this is to receive the initial message. Let's see. Receive the initial message and then send confirm output from here. Okay, and then we run our loop. So for x in range, for x in range, 0, start with 1 and go on for 21. I think it's, yeah, I think they're looking for 20 steps, right? 20 steps in 10 seconds? Okay, we do something. We do 2, 3, 4. We run, what's the name of the function? Look function, this should be called lookup function ADDI. Lookup function ADDI, and then we run send answer. Send answer, and then that's wrapped up in another function, which is lookup function address. So we run lookup function address, which is passed over to send answer. Is that it? Is that all we need to do? I'm not sure. You know what? Let's see how it works. Stop process. Key error name. What's happening here? Line 164. What? Sent answer this thing. Okay, and then okay, maybe we shouldn't do it like this. So we'll do lookup function addy, and we'll lookup function addy, and we'll save that as something. Lookup equals lookup function addy, and then I guess we can't really nest this. We need to run the thing. We run lookup function addy. We need to save it as lookup. Then send answer with lookup as the thing that we're going to send. Hold on, let me take a look at my function. So p send line answer bytes, send answer answer bytes. Should I be splitting this up more? Return hex address bytes. So lookup equals lookup function addy, and then we just run. We do it up here. Jason says this challenge has chopped our time. Well, I mean, you know, sometimes we need to spend the time doing the exercises. But after we finish this exercise, maybe we'll try doing some other stuff. What time is it right now? After this, we got about well, if we finish this up soon, we have an hour to do another challenge. Okay, I think what we should do is we should split up this function here, because it seems like it's doing too much. So we just want to get the name of the function. Lookup function name. That'll be one function, and that can go up until function name equals this. Okay, and then this will be return function name. Okay, this will be fed into the next function, which is get function address, or get function addy. Jason says, I hate getting IT certs, they're a scam. Which IT certs are you talking about? Are you talking about all the IT certs? Because they kind of they're kind of a necessary evil. People want to see that you know some stuff. I like learning from people like you. I mean, the best thing to do is to have experience, but having experience is just tough. Jason, IT Solutions, CCNA, CompTIA stuff. I think the stuff that the information you can get from the certifications are good, but get function addy, we need to take in the function name. function address equals elf.symbols function name, and then we return the hex addy bytes. Okay, and then send answer is going to take in the answer bytes. Okay, so that means we run in a loop. Lookup function name, and we're going to save that to lookup. Lookup equals lookup function name. We feed that into get addy bytes. Get lookup function name, get function addy. Get function addy. And we take in Adolf D Gamer. I joined in Reddit. Hello, nice to see you here. That's some name. Okay, addy bytes. Get function addy. We're going to take in the lookup. And then we're going to, well, let's give this a variable name as well. What are we going to call this? Addy equals get function addy, and then we send the answer with addy as the thing. Just a second. I'm a cybersecurity student. Yeah, just, I mean, probably... So, Gamer, tell me about your cybersecurity, well, tell me about your tech background. Have you learned much about tech stuff? Are you able to do coding? Have you coded in Python? Have you done any web development? Let me know. Okay, send answer addy. Let's see if this works. So we've got a big for loop here. What happened here? So everything works up until here. We sent the hexadecimal address. Shake, hello, nice to see you here. What is up? Okay, so I think it times out after the first request because we didn't send enough stuff. Okay, so let's see. So we send line, and I think we need to send answer. Send line answer, and then I don't think that was enough. Because the next lookup function name gets stuck. I think it's because there's more stuff to receive afterwards. Or at least that's my guess. So we're just gonna do another p.receive. p.receive, I don't know, 1024. Let's see if getting more information before doing the next thing works. Started my master's in cybersecurity and I need some help. What do you need help with? You started your master's in cybersecurity. What did you study before? What did you study before you started your master's? Okay, so this works now. It works now because sent the answer, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we sent 20 of these. After we send 20 of these, we need to receive the flag. So for something in range, run that whole thing, and then we need to get the final answer. And to get the final answer, we should run something. P dot. We'll just get a bunch of information. And we'll print it out. Last message. Print last message. Congratulations, this is the flag. The flag is not here, not the real flag. Okay, well, all we need to do now is we need to send this to the server instead. So if args remote, p equals remote. If args dot remote, so do we just send remote with the Python script? Python remote. Wait, how do we actually? Okay, hold on. Okay, let's go back to the challenge. Challenge is here. Okay, so you need to do remote in all capital letters. And completed my undergrad in computer science. Yeah, so okay, you're a cyber student. You did undergrad in computer science. I understand this. What are you trying to? What help do you need? What help do you need from me? What are you looking for? Okay, so we need to make sure that it is all in capital letters. Remote. Okay, this is too slow. Oh wait, it's not too slow, it worked. Okay, I got the flag. Alright everybody, haven't done this in a while, but you know, let's redeem this one.
What are you?
I'm system root.
Not especially root, but we managed to finish the challenge. Okay, great. Belmung, thank you. Flag this thing here. Let's go ahead and submit this thing. Jeez, that took a while. Okay, and the important thing is that we learned something. We learned something, and we can go ahead. Well, we'll include everything here. Because having more stuff is better than having less stuff. I kind of thought that this this process would never end, but I guess you get to the end eventually. Okay, so let's see. We're editing this file over here. Method of solve. So this Python script gets the job done. Paste in the script. I don't know why when I try to explain my situation, it's not showing. When I try to explain my situation, it's not showing. I'm sorry, yeah, I don't see any messages from you. I mean, all I see is your last message is saying that you completed your undergrad in computer science. But yeah, you can send a message on over at Reddit, and I'll take a look at it later. Okay, so the concept is using pwn tools to test a binary locally and remotely. Okay, let's commit those changes. You know, because we haven't done a nice easy challenge in a while, let's do one over at Docker Labs. All right, Docker Labs, sure. We got the easy challenges. Do we have any new ones? Ping CTF. Ping CTF. I don't know if I've done this one before or not. Let me check. Oh, I have done this one. Yeah, I've already finished that box. Okay, let me choose a new one then. Let's try a medium level one instead. How about fooding? I mean it's got the word food in it. It couldn't be bad, right? Alright everybody, if you want to download and deploy this machine yourself to give it a try, you can do it over here. How much longer are we going to go? We're going to go about 50 minutes. I'll put 50 minutes on the clock, and then we'll see if we can solve this box in 50 minutes. Probably not, but we'll give it our best try. Okay, so Kevin Capo says, could you pass in a Google interview? I don't think so. I do not think so. You look like a pro. Not a pro at all. Not a pro at all. They ask a lot of difficult questions during Google interviews. I don't think I qualify. Okay, so we're gonna be doing some Docker hacking stuff. So it's gonna make a bunch of tabs. Docker container. Let's give myself a funky color. How about purple? I like purple. So we've downloaded the virtual machine. Sorry, the what is it called? We actually haven't downloaded it yet. Fooding.zip. We need to download this as 473 megabytes. Click on download. Hopefully it doesn't take too long. But Kevin Campos, welcome to the stream. Hello, nice to see you here. Let's give you a let's give you a Nyan Cat. Welcome in. Okay, so okay, we got fooding over here, and we just need to unzip this file. So the challenges over at Docker Labs, which is this website we're using over here, they're Docker containers. They're Docker containers that are intentionally vulnerable, and we're going to be hacking against them. We're going to be deploying them to our machine, and then we're going to be hacking against them. So the first thing we need to do is unzip the file. And then we're going to deploy the Docker container, and it's going to be sitting on top of our Kali Linux machine here. So let's see. Just need to we need to run this auto deploy script to run it to deploy the machine. We will run the script with the fooding.tar file we just unzipped. Permission denied. Oh, this doesn't work because we're not running a sudo. Okay, so now we've deployed the vulnerable Docker container. I have no idea. Hello, how are you? Did you miss me? Of course. I have no idea how much I missed you. Okay, so we've got our IP address here. The Docker machine is running. Everything is in Spanish because this is a Spanish website that we're using. We're using first Italian websites and then Spanish websites. We do everything but English websites, apparently. Okay, let's run our Nmap scan. How much longer are you going to be streaming? So we'll probably be streamed for another 46 minutes. You should see like a timer up there. By the time 46 minutes elapses, it should be about dinner time for me. And right, so the first thing we do is we run an Nmap scan. Nmap is going to let us know what ports and services are available on this remote server. This is a Docker container in this case. It's got a bunch of open ports. I'm very surprised. Why am I not seeing the challenge? So you just go over what you want to do if you want to do this yourself. Actually, I can give you the direct link to download the thing. The direct link to download the file is over here. My professor has given me a challenge to complete. Okay, what can you tell me about this challenge? And can you tell me where you're, if you don't mind, can you tell me what country are you studying in? You don't necessarily need to tell me which university it is, but if you could tell me which country you're studying in, it would help me out a little bit. Okay, so we've got a bunch of different ports open. We've got port 80, we got port 443. Port 443. Huh. So we actually have an HTTPS, like an encrypted web page. That's okay, so yeah. What else do we have? 1883, which is unusual. It also says USA, okay. There's a thunderstorm in Waco, Texas. I have no idea. Are you in Waco, Texas? Okay, so I'm not too sure what we need to be paying attention to here. We got a bunch of open ports and some kind of unusual port numbers as well. We've got like 3 web pages. We got 4 web pages. This might take a little while. All right, so this is our Nmap scan. Nmap scanning. Give this a color. Let's make it blue. And the next thing, web app enumeration. It looks like we've got a lot of web apps to deal with over here. Can give this another color. Let's make it green. There's a CTF challenge I have to complete. Thank you very much for following Kevin Campos over on, was that YouTube or Twitch? That was Twitch. Thank you very much, Kevin Campos. Okay, so you have a CTF challenge that you have to complete. I can give some advice. I can't solve the challenge for you. I can't help people cheat at CTFs. That's not what we do. I can take a look at the challenge. I can make a comment on, like, you know, what you might want to do to start the challenge. And that's about it. If you can drop a link to the challenge, I might be able to take a look at it real quick. Okay, so the Nmap scanning, let's do the scan one more time, but this time we'll do it a little bit slower. We'll also we'll save the output to nmap.txt. Neems, hey, nice to see you here. We're just doing a little CTF challenge for the next 40 minutes or so. Why are you giving me these error messages? How about we run some what web? In 721702. So what web is a little service that lets you know some information about a web page. Okay, so it's an Apache page, Apache 2. It's a default Apache page. Goldfish the Bounty Hunter. Hello, nice to see you here. Connect to the MQTT. I haven't decided yet. You haven't decided yet? So they just told you needed to. It has to be related to information system security. Information system security. That's pretty broad. Goldfish the Bounty Hunter. Yeah. I mean, I'm not super familiar with what is the word? With enumerating MQTT. But we might have to give it a try over here. Okay, we got Jetty. Jetty? We've got a version number for this software, so anytime we see a version number, we could start enumerating against it. So we can look up whether or not there are known hacks for this thing. Nope, not for this thing. Sniff some local ports via the browser. Yeah, I think we can do that. We just need to figure out which ports we want to investigate first. So I mean, we've got our stuff on port 80. Let's take a quick look over there. (17.17.02). So this is the Apache default page. Most of the time you're not going to be able to get anything from these pages. Sometimes in really CTF-like boxes, they'll have some extra stuff hanging around over here in like comments or something. But I don't think this is the case here. Okay. We can also check out port 443, which is the HTTPS version of the page. Potential security risk ahead. Okay, learn more. Well, actually, no, I actually don't want to learn more. Advanced. So this is a self-signed certificate. This is pretty normal for these type of CTF challenges. Accept risk and continue. Docker Labs. Okay. Food. I have no idea. Asks, what are the specs of my computer? I think I've got a command called specs. There you go. Henky asks, am I too late to join? No, if you want to do some Docker Lab stuff, it's over. Let me grab the link. Fooding. If you want to try this one here. Okay, so what is this web page? Docker Labs, simply fresh and delicious. Okay. What's going on? So this is a single page application. And what else? So we've got some components.html. Components.html, huh? It's kind of funny that it's using this. Okay, so copyright 2025, made with love by Dev Crud. Dev Crud, I've never heard of these developers. Of course, that doesn't mean very much. Dev Crud, okay. Get a curl or dig request. Get a curl or dig request. I mean, I don't think we need dig because we're not dealing with real domains. Dig, well, I mean, usually when we use dig, we need to have like a domain. There's no domain in this case. Well, at least I don't see one. Let's see if we can spot anything in the comments here. Plantilla gratuita bootstrap 4 point something something. I wonder if this is like a legitimate piece of software. Okay, I don't know, let's call this research. Plantilla gratuita. Let's see if this is actually a thing. No, don't see anything. Check the application. Is it using JS or PHP or Python? Bootstrap is a front-end library. Yeah, so Plantilla gratuita is the name of the library, I guess. Let's see if... I hope there are no hints hiding in the comments over here. Core scripts, wow.js, foodhut.js. Foodhut.js sounds like it could have some custom code in there. So let me check that out. Okay, now you have a few domains. We should get open ports. Get open ports. We have domains? Where is there a distinct domain? DevCrud licenses, Food Hut landing page. I wonder if there's some sort of vulnerability in Food Hut. Nope, nothing for Food Hut. The other thing we could do, what do we have over here? We'll do whatweb for the HTTPS version of the page. Maybe it can give us a little bit of extra insight. Docker Labs, Plantilla gratuita bootstrap, great. jQuery, Okay, so let's run a little bit more web app enumeration against the HTTPS version of the site. Let's just run some dirb first. There's an assets directory, index.html. So the assets directory is listable. Okay, probably nothing we really need to worry about over here. Gamer says, can I get your Instagram ID? I don't use Instagram, but like I said, you can send me a message over at Reddit. Over at Reddit HackerFrogs. There you go. Yeah, okay. Index. We didn't find anything else here. Just for fun, I'll do the same thing on the other page. So index HTML. Wait, what? There's an HTTPS directory on the HTTP page? I need to check this out. That is weird. It's weird that there's just a copy of this thing. It's early morning where I am, where I need to do physicals. I have to flatten this tummy. No worries, no worries. If you need to get exercise, that's an important thing to go get. I wish I could get some more exercise myself. So, HTTPS, huh? So this just a copy of the website. Okay, so if there's a copy of the website here, what can we do with this? I guess we'll take a look at, we'll do a more thorough directory busting attack. So let's see, let's try GoBuster. Zip, HTML, HTM, some other stuff. We're looking at 172.17.02. I'm pretty sure you can send me a direct message. So you can click on my username. I'm pretty sure you can send a direct message inside of Reddit there. AMD Ryzen 7, is that what I have? No, I've got a Ryzen 5. Looks like a misconfiguration in Apache conf. Yeah, I mean, how can we take advantage of this, though? If that's the case. Okay, you got server status. What else do we have on the box? So we got port 80, we got 443, and I've noticed that there was a weird... We got MQTT. I don't know if I want to immediately look up this stuff, because I'm not very familiar with MQTT. There's another HTTP page on 8161. I guess we could check that out while the other stuff is loading up. 8161. Activate. MQ has a vulnerability. Are you sure? (8161). Oh, it's basic auth, huh? So this is supposed to be Jetty, right? 8161 Jetty. Does Jetty have... So you said something about the MQ. Henke says, check it on ActiveMQ. ActiveMQ? We got web shell upload. We've got, well, we need to know what the version number is. ActiveMQ, that doesn't tell you what version is being used here. I mean, we might be able to get the version number if we connect to it. Let's see, netcat. Java running some Ruby. Nice. Where are we? I've done some machines using ActiveMQ before. Oh, awesome. I have no idea. Says I'm getting an AMD Ryzen 7 64 gigs of RAM, 5060 Ti. Sounds pretty good. What are you gonna do with that machine? Are you gonna be doing some gaming or some other stuff? Okay, so how do you how do you communicate with ActiveMQ? So what tool do I use? Alright, let's figure it out. ActiveMQ Connect. Classic connection URIs. Let's just ask our good friend Claude. I want to test ActiveMQ with security tools. What tool should I use? I am using Kali Linux. So public system, you must have a client MQTT to sub to a topic. Check the Jetty JavaScript. It's probably hard-coded with a password token. I don't know for sure. There are too many things we can investigate on this box. So let's try... Let's see if there are any Jetty default credentials. Because we got some basic auth over here. Jetty itself is a web server, and a servlet command container does not inherently come with a set of default credentials for administrative access, typically configured by something something. When ActiveMQ Classic, when integrated with Jelly, ActiveMQ Classic often uses admin. You know, could it actually be admin? I don't know. Yeah, okay. It sure is awesome when you leave default admin, default credentials on your web application. Gaming and some 3D modeling and animations. Sounds good. Okay, so welcome to Apache ActiveMQ. What do you want to do next? Manage ActiveMQ broker, see some web demos. Well, I mean, it sounds like it would be nice if we could go over to the admin page. Okay, so we got some information here. What do we got? Broker localhost, version 5. Okay, so we've got the definite version of ActiveMQ. So if we've got the version of ActiveMQ, let's just... I mean, I can read, but it looks like this is not the abusable version of ActiveMQ. Looks like Jetty integrated to ActiveMQ. Yeah. Hold on, everybody. I should change up my music for the next 20 minutes or so. What do we got? Oh, here's some here's some classic what is it called? Like old school gaming soundtracks. Let's skip over to this part of the soundtrack. Okay, what do we got? So we got Jetty, and we've got ActiveMQ. XML, subscriber views XML. Let's see, admin subscribers.jsp. Let's see if I can just download that using wget. Unauthorized. Okay. User passname authentication failed. Can we... Sla, hello, nice to see you here. Can we use wget with basic auth? Wget help. Can we include like a username password here? User agent, let's see. Auth no challenge. User pass. You know what? that's, hold on. Okay, there's no basic, I mean, there's username, password here. Proxy username and password if no command is set. Let me just download it by clicking on the thing. Topic views, we got subscribers, the XML does not have to be any style information, so there's nothing here. There's nothing here, okay. Let's take a look at topic views. Master broker, consumer topic. Don't know if there's anything super important here. This XML file doesn't have anything in it. We've got a graph. Graph doesn't have anything in it, okay. Okay, useful links, documentation. This all goes to an outside website, which I don't think we need to do. ID equals this. Let me look up this specific version of ActiveMQ. I just want to make sure that it's not vulnerable to something. Jason IT Solution says, Ryzen and Intel, which one is better? Well, I mean, that's the... When are you going to start a gaming channel? And let's start with the game from the debts. I will watch all the videos. I'm afraid ActiveMQ. Okay, so is there an actual hack for this? Okay, so you will need the ID and topic to connect to for the sub, and then query for open topic for the sub. I just want to make sure that there's no obvious, like, you know, abuse that I'm missing here. Apache ActiveMQ is vulnerable to remote code execution. You don't say. This is from a couple of years ago, so I don't know if this is relevant here. What is the latest version of ActiveMQ? Just let me look that up really fast. The latest version of ActiveMQ seems to be 5.16, and we're looking at 5. What is it? 5.15. Okay, let's take a look at the GitHub for this. 5.15.15, I think that's the one we're talking about. Nothing for 5.15. So we're dealing with 5.15.15. Vulnerability may allow a remote attacker with network access to a broker to run arbitrary shell commands by manipulating serial class types. Okay, so Henke says you will need the ID and topic to connect to the ID, connect the ID for the sub, and then you can query to open topic for sub. Okay, so, I mean, we were also asking about advice from our good friend Claude. but apparently we didn't get anything. Oh, is it working? Okay, for testing ActiveMQ, here are the best security tools available on Kali Linux. ActiveMQ has several known vulnerabilities within these modules. Okay. Nmap, initial reconnaissance. Method 3, ActiveMQ scanner, which is a specialized tool. Okay. Manual testing with curl in browser. Automated testing scripts. After dinner, will you be live again? No, I don't. I don't go on live after I finish dinner. But yeah, I'll be back. I'll be back. What is it? Well, I mean, today's Friday. We'll be back on Monday. Go ahead and send me a message on Reddit. I'll try to answer as fast as I can. Okay, quick command reference. Nuclei. Well, I mean, the other thing that we've been trying to do is we've been trying to use nuclei a little bit more because nuclei is one of those all-in-one scanners for the entire server. So let's try a little bit of that. Let's call this nuclei. So just provide nuclei target and then the IP address. So I've actually seen some pretty good stuff from this program. It's kind of similar to Nmap. The output looks a little bit nicer and cleaner than Nmap, of course. Okay, let's leave this alone for right now. So we got the Jetty server here. Where is it? I wonder if these other pages are just kind of like red herrings or rabbit holes. We got ActiveMQ here. We got the ID number. There are videos with 865K viewers. That's a lot. What are we talking about? I'm not necessarily on YouTube to get absolutely the most viewers, because I want to do the stuff that I want to do, and I want to do stuff on security stuff. Send. Scheduled. Send network. Connections. Subscribers. Okay, we got nothing here for network. Scheduled. Nothing is scheduled. Send foo.bar. That's great. Same game. Check for topic. Topics. Okay. Number of consumers. Messages enqueued. Messages dequeued. Jason asks, how long does someone need to practice in a day on average? Practice in a day on average? I mean, that's not an answer that has a definitive answer. To get better. What's your goal? I mean, the goal is to get better, but you need like a goal to work towards, right? Okay, so we got these topics over here: advisory connection, consumer topic, master broker. You know, I'm going to look at my... Let's see. T5, hello, nice to see you here. You got a question? Yeah, you can ask questions, that's fine. We're just working on stuff in the background, but if you have any questions, feel free to ask. MQ? So the name... Yeah, I've never done a machine on ActiveMQ before. So I need to do a bit of research on how to do this. Let's see. T5 asks, I have my other laptop. I have on my other laptop, port 80 is filtered. How do I deal with it? Port 80 is filtered. What are you trying to access right now? So which you say on your laptop port 80 is filtered. Does that mean you can't... I'm not following here. What are you trying to do? Okay, send. Let's support and log out. Queues, home. Python script to communicate using MQ key to the topic, then Handcaster, hello, nice to see you here. Create a Python script to communicate using MQQ to the topic, and then a few messages to read. I mean, there's probably some sort of MQQ like tool out there, like MQQ, or like It's called like MQTT, I think. MQTT pen testing tool. MQTT pen testing tool. Shout out this channel with the gaming channel. I don't know about that. Okay, so MQTT pen testing guide for penetration. Okay, this sounds like something I want to look up. Okay, what is MQTT? This is a publish subscribe network protocol for Internet of Things. Default ports are 1883 and 8883 over TLS enumeration. So you do this kind of mmap scan right here. Let's give it a try. Over with nmap. Get out of here. Okay, so we know the target IP is this. If I'm not forgetting, the name is like Mosquito something. Bad advice giver says, make sure you're using the right Windows profile for the firewall. Port that you open, also make sure you can reach it locally. Okay, so we've got master broker, topics and their most recent payloads, ActiveMQ advisory, master broker. Okay. So how do we get more information from this? Let's keep on reading. Mosquito version something something. What do we got? It doesn't tell us what the version number of the thing being used is. Oh wait, we didn't ask for it. Let's run it again, but get the versioning information. We're probably not going to finish this box tonight, but it's actually pretty. This has been pretty interesting so far. We've got some new. We have some new technology that we haven't hacked against before, so that's nice to be able to tackle. What do we got? Mosquito as an MQTT's utilities that includes a broker and publish subscribe clients. We'll use Mosquito to interact with MQTT. So Mosquito, is this installed? Mosquito. Oh, it is installed. Let's see. Bad Advice Giver says, example, public domain, private. It's easy if you know, if you know it. Well, I mean, if we know it. Okay, so we got some, so Mosquito, how to subscribe to a topic. Mosquito sub, H example, and then path to topic. Local, port, Guess we could give this a try. Protocol version, specify username and password. We don't have a username and password. We do have a specific port. I don't think... Alright, what do we got here? So example.com. We've just got a... You were talking about a gaming channel a few months ago. A gaming channel? I don't think we've ever... We've done gaming on the channel, but this is not a gaming channel. We do play games every once in a while. Most of the time we try to make sure that they're puzzle games or, like, you know, something that's kind of related to hacking or cybersecurity. Okay, path to topic. We don't know the path to the topic, or do we? Let's check. So let's see, topics. So we don't know. Will this tell us what the path to the topic is? Is it just this? Check for master broker. I think I saw. Yeah. No, wait. We've got the path to topics over here. Never mind. Okay. And do we need to add this thing on top? Mosquito sub not found, but can be installed with sudo apt install Mosquito clients. Do you want to install it? Yeah, sure. Why not? Goldfish Bounty Hunter says, use the MAC. Are you talking about the MAC address? Okay. Was I not supposed to include the colon at the end? I think that might be the case. What tab am I using right now? This is the Nmap tab. I should probably be using another tab for this. Let's see. Let's call this Mosquito. Okay, so I guess this... I mean, if this subscribes me, I don't know if it actually gives us any information here. I'm forgetting the flow, but you need a client to register and as a subscriber to read the topic. Okay, you need a client to register as a subscriber. Let's take a look at the guide. Subscribe to a topic, interaction. To get the Mosquito's version, run the following. Mosquito sub t. Okay, so let's give this a try. Mosquito's here. I don't think this is giving us anything. Am I using the wrong port? Because we're not getting we're not getting any response. Publish it to a topic. Showdown tools. So MQTT Pwn intends to be a one-stop shop for IoT broker, pen testing, and security assessment operations. I mean, if there's a big tool, I guess we should take a look at it. Okay, and MQTT Pwn, great. It doesn't necessarily teach us how to use it, of course. We got, documentation. Okay, so documentation is here. Prerequisites, installation, database, virtual environment, all sorts of great stuff. I think it would be cool if you do a gaming channel, just saying. I might do some gaming, like... Yeah, I mean, I try to fit in some gaming every once in a while, but it's yeah, like I said, it usually has to do with hacking and cybersecurity, or like puzzle games. Not necessarily like, action games or like shooters. I used to play a lot of like some simulation games and like strategy games, but I don't know if I have the patience for those things nowadays. You ever tried Factorio? Factorio, I mean, that might be something I could do. Factorio is very... What is it called? It's like an optimization game. But I have heard of it and I've seen people play it. Watching Factorio is not very... I don't find... Message you in Reddit. No worries, no worries. I'll take a look at it a bit later. And you know what? I think it might be getting pretty close to ending time. I'm gonna need to revisit this this box because there's a lot of stuff that I haven't done before here. But let's take a look at who else is streaming right now. So twitch.tv. Just a second. We should also look up and see if anybody is on the InfoSec Streams site. So InfoSec streamers. Don't forget to check the topic. Yeah. Okay, Het Tannis is also streaming right now. Let's take a look at what they're doing. You watch this while you eat for some MQTT info. Thank you very much, MC25. Let me copy that over. Because it seems like it's a pretty big topic. Oh, that's that's John Hammond. Okay, I see. All right, so Het Tannis is doing what? Getting the job in Linux administration. Okay, so this is tech related at least. Let's go ahead and raid into Het Tannis. Before we go, we're going to be doing our next stream on Monday. We don't have the schedule up yet, but I'll probably have the schedule up by the end of tonight. So everybody, we'll be back on Monday, but we'll raid into Het Tannis, and we'll probably do this box again the next time we stream on Monday for the last thing we're doing. All right, so everybody. When you get to Het Tannis' channel, if you give this message, OSFrog, hip hop hack, OSFrog, I would really appreciate it. All right, we're going to be back on Monday. Thank you very much to everybody for joining in with the chat today. And ready to raid? Have a great weekend, and we'll see you next time. 3, 2, 1, HackerFrogs out.